Hello.
Hello.
Sir, good morning, sir. Raghu, sir. Shall we start, sir?
Start chedama.
Chestam, sir.
So I am ready, madam.
Okay, sir. Yes, we'll start.
Shall we start?
Yes, sir.
Thank you.
Shall we? Okay. Yes. A very good morning to you all. Good morning to all the participants of the National Workshop on Recent Trends in Technical Session. We have eminent speaker, Dr. V. Raghu Garu, scientist, Space Application Center, Vijayawada. So I will read out his brief biographical sketch. Dr. V. Raghu Garu has completed his MSc during 1983 and PhD during 1990 in geology from Sri Venkateswara University, Tirupati, Andhra Pradesh. He was awarded CSIR fellowship during his research. As a research assistant, he worked in a project entitled Hydrological Investigations for PSLV at Char Center, Sriharikota from 1984 to 1986. He joined Andhra Pradesh Space Application Center APSAC in 1992 and retired as scientist SF at APSAC during 2021. During 1996 to 1998, Dr. V. Raghu was in charge APSAC field office at Desert Development Program DDP Anantapuram. During this period, he helped the district administration in understanding the thematic maps and the recommendations made in land and water resources action plans. Dr. Raghu assisted in implementing, monitoring, and evaluating the watershed development works, as well as trained both governmental and non-governmental organizations in various natural resources-based developmental programs. As a senior scientific officer, AP State Remote Sensing Application Center Abstract, Dr. Raghu worked on duty with Social Welfare Department, Government of Andhra Pradesh under Scheduled Caste Special Plan SCSP from 2012 to 2014. So he carried out a district and mandal-wise spatial distribution of SC population during 2001 and 2011 census. He located various types of social welfare hostels and schools of Andhra Pradesh, Social Welfare Residential Educational Institution Society, APSWREIS in GIS format. Prepared maps for AP Scheduled Caste Cooperative Finance Corporation Limited on physical and financial achievements since inception of the corporation. Dr. Raghu identified mandals to establish boys' school in each district based on 2011 census and existing the residential schools for APSWREIS. As a resource person, Dr. Raghu delivered lectures on applications of remote sensing and GIS at AP Study Circle, Hyderabad. His field of interest is exploration for groundwater and mineral resources, watershed development, and disaster management using geospatial technology. In his 29 years of experience at APSAC, he is involved in 42 projects sponsored by state, central, and international agencies and worked as a project coordinator for more than 20 projects. He is a life member in various FX scientific bodies, namely the Indian Society of Remote Sensing, ISRS, Dehradun, the Geological Society of India, GSI, Bangalore, the Indian Society of Geomatics, ISG, Ahmedabad, and the Indian Geophysical Union, IGU, Hyderabad. Dr. Raghu acted as an examiner for conducting YOOC for MSc, MTech, and PhD students, paper setting for MTech, MSc, and PhD courses, and conducting practical examinations and evaluation of answer scripts for MSc and MCA courses. Dr. Raghu acted as a reviewer for various national and international journals. He has 45 publications in proceedings for the seminars, conferences, and in the journals of national and international repute. So with this brief biodata, so may I welcome Dr. Raghu Garu to deliver his speech. Thank you, sir, for your valuable time for sparing with us. Thank you.
Thank you. Thank you. So, shall I start, madam? Shall I start now?
Yes, sir. Yes, sir. Please go ahead.
Okay. Good morning, all of you. I am V. Raghu. I'm a retired scientist from Andhra Pradesh Space Application Center. Just now, madam has read out my brief biographical sketch about me. Thank you, madam. And today, we are going to discuss about hydrogeomorphological mapping using remote sensing and GIS techniques. Next. Next slide, please. So to say something about our organization APSAC is an IT based on is an information technology organization, and the following information technology enabled services are provided to all the government departments. That is in remote sensing, digital image processing, geographical information system, as well as as well as GPS. We have a very vast centralized satellite data bank and digital data for the entire state to provide services in mapping, monitoring, and modeling of natural resources using GIS and catering the needs of various governmental organizations in the state of Andhra Pradesh as well as to the central government. Next slide. Next slide. Hello. Next slide, please. And this is the satellite mosaic of our Andhra Pradesh state. This is basically from Landsat 8 satellite data. If you see on the western side of this particular state, you see very area with less greenery. It is a false color composite image, whereas vegetation is seen red in color in this false color composite. And when you see from left to right, the area surrounding this Kurnool, Anantapur, Chittoor, and parts of Prakasham and Nellore districts are all they are not covered with any greenery, because this area these areas are highly drought prone areas with high aridity index, high temperatures, very low rainfall area, and very high wind velocities, and all these things. These areas are all highly drought prone. When compared to when you move from left to right, as you progress, districts like Krishna, Guntur, East Godavari, West Godavari, Srikakulam, Vijayanagaram, Visakhapatnam, all they are very experiencing very high rainfall in those areas, and they are very green color. These are very fertile areas when compared to the Rayalaseema districts. Next slide, please. And this is the state of Andhra Pradesh with 26 districts, and all the district boundaries are shown, and all the revenue divisions are all shown in this particular area. And there are 72 revenue divisions all over the state with 670 mandals. These are the mandals and revenue divisions and district map of Andhra Pradesh. These are the 26 newly formed districts. Next slide, please. This is the geology of Andhra Pradesh. Hello. This is the geology of Andhra Pradesh, and it is consisting of right from Archean to recent. Archean says from Charnakites, Conolites complex to granite gneiss and hornblende bitite gneiss granite, and schist, limestone, intrusives, quartzite, basalt, sandstone, laterite, as well as alluvium. This is starting from Archean to recent alluvium. Like that, these are all the geological formations present in our Andhra Pradesh state. Next slide, please. This is the satellite mosaic of our Kadapa district with all districts and mandals located in this particular district. It's a satellite mosaic, and this is our Mylavaram reservoir. This is the backwater, the Somsila reservoir. This is our Pottur Veerabrahmam reservoir, and this is Annamaya reservoir. Like that, these are the reservoirs, major reservoirs in our Kadapa district. And this is the satellite mosaic of our Kadapa district. Next slide, please. This is our Kadapa basin. As you know, this is the crescent-shaped Kadapa basin. You have all studied about this in detail. And this covers around 44,000 square kilometers area. It's a crescent shape, hosting a variety of minerals with very beautiful geological formations. It is a IRS P6 list 3 satellite mosaic. IRS P6 list 3 satellite mosaic with 23-meter resolution. Next. Next slide, please. This is again our Kadapa basin. This is a Cartosat 1 and list 4 mosaic. This resolution of this particular image is 2.5 meters. So this is a very high resolution satellite data. This is a combination of this hybrid image with a combination of Cartosat 1 and a list 4 IRS P6 list 4 satellite data with 2.5 meter spatial resolution. Thank you. Next slide, please. This is our part of Rayalaseema with drainage network. This is Karnool, Anantapur, Chittoor, Kadapa, Nellore, and Prakasam districts. All the drainage network is given. This is the backwaters of our Srisalam Dam. This is the backwaters of this Zomsila Reservoir. And this is the drainage network in these 6 districts. Next slide, please. This is the minor river basins in our Rayalaseema, 4 Rayalaseema districts. So based on the drainage, all the minor basins are delineated. All the minor basins are listed out here with the numbering. Next slide, please. This is a drainage map of our Kadapa district. You can see this now. This is Chitravati, this is Penner, this is Papagni, this is Cheyyar, and this is the major rivers flowing in the districts. This is again Kundu River, this is again Sagileru River. All these major rivers are flowing in our Kadapa district. Next slide, please. This is again drainage and surface water bodies of our Kadapa district with Mandal headquarters located in this district with light base information like road and rail network. Next slide, please. Next slide, please. This is the minor river basins for Kadapa district. This is Papagni River Basin. This is Cheyyar River Basin. This is Lower Pennar. This is Middle Pennar. This is Kunderu. This is Sagileru. So like that, based on the drainage network, all the minor river basins are delineated and shown in our. These are the many number of basins present in this particular district. There are 1, 2, 3, 4, 5, 6, 7, 8 river basins are present in our Kadapa district. Next slide. So as far as the rainfall is concerned, our Kadapa district has 710 mm of rainfall, seasonal rainfall distribution. Among the 710 mm rainfall, 402.4 mm is in southwest, comes in southwest monsoon, that is from June to September. 239.1 mm in the northeast monsoon, that spans from October to December, and 2.4 mm rainfall in during winter season, that is during January and February, and 65.7 mm rainfall during March, May, that is in summer season. The percentage distribution of rainfall is 56.7 mm in southwest monsoon, 33.7% in northeast monsoon, and 0.34% during winter, and 9.3% during summer. This is the seasonal distribution of our rainfall in Kadapa district. Next slide, please. This is the histograms represented in our Kadapa district, and there are some maximum rainfall years that is went up to beyond 900 during 1996, during 2007, 2010, like that. There are 3-4 years which experience a very good rainfall, whereas about 800 mm experience rainfall comes under 1, 2, 3, 4, 5, 6, 7 years. We have experienced above 800 mm rainfall, and the lowest rainfall is recorded in 1999, that is around 400 mm only, which during that year we have suffered a lot because of low rainfall, because of drought conditions. Next slide. This is under Neeru Chettu program during 2018. Our office was asked to conduct locate rainwater harvesting structures. So based on that, using remote sensing and GIS techniques, we have verified the satellite data and triple sheets, and we have identified 325 rainwater harvesting structures, mostly rockfill dams during first and second order streams. During third and second order streams, we have identified 34 structures. And from second order to third order streams, we have major structures, big structures. We have identified 12 structures. So this is again, we had collected data from groundwater department, and what are the what are the mandals that are critical in nature, and what are the mandals that are semi-critical, what are the mandals that are overexploited. So all these things are shown in this particular area. And Babu Slogama, all this like this, these are all this pink color is overexploited, this is orange color is critical, this is light green color is semi-critical area, and the white is are all safe areas. These are the problematic mandals in our Kadpa district during 2018. So the more attention should be paid on these particular overexploited critical and semi-critical areas in terms of rainwater harvesting structures are concerned. Next slide, please. This is again road network of our entire Kadpa district. APSAC carried out a very major project for Panchayati Raj department, and we have covered all the roads of Panchayati Raj department, and we have a very good database as well as the road network is concerned. We have collected the information on roads from Panchayati Raj, R&B, and we have mapped for the entire state of Andhra Pradesh. And this is the road network of our Kadpa district, Andhra Pradesh. This is mostly Panchayati Raj roads. Next slide, please. This is again slope map of the area. So based on the digital elevation model, this slope map is derived. Earlier, we used to generate slope maps by physically measuring the distance between the two contours of Survey of India topo sheets. And now it has technology has developed, and using the digital elevation model, this slope map is derived. Generally, there are 7 slope categories, from nearly level to very gently sloping, moderately sloping, strongly sloping, moderately steep sloping to steep sloping, very steep sloping. Like that, there are 7 categories, and the percentage of each and every slope category is given like 0 to 5, and the last category is given as more than 35% of the slope. This is the slope map of our Kadpa district. Next slide, please. This is again geology map of our Kadpa district. This is Geological Survey of India map prepared by the Geological Survey of India. We have borrowed this information from Geological Survey of India, and I am showing this map for your benefit through GS. This is a GSA map. You know, this is the all granitic terrain covering Raichoti, Lagradipalli, Sundupalli areas, and this is all Kadpa Basin covering from Gulchervu to Srisailam quartzites and all these things. Of course, Srisailam quartzites are not present in this particular Kadpa district. From Gulchervu to Kambam formations like that, up to that we can see in this Kadpa district. Next. This is the detailed legend, right from Archean to Precambrian. From Archean to Precambrian, all these geological formations are listed out with symbology. Next slide, please. Next slide, please. This is again structural map of the area. So it's a very big subject again, structural point of view. There are fractures, joints, and lineaments, and there are different types of structural features are there, like some of them we are given here, like ridge parallel, axis fold, and scarp parallel, ridge parallel, lineaments, fractures, folds, joints, and this all granitic terrain. These all granitic terrain. So these red lines are all dolerite dikes, and this is all lineaments and fractures and faults in the rest of the Kadapa district. Next slide, please. Next, coming to our groundwater, as you know, it's a major source for all the purpose of water requirements in India. More than 90% of the rural and nearly 30% of the urban population depend on drinking groundwater for drinking water purposes, and it accounts nearly 60% of the total irrigation potential in the country, irrigating about 32.5 million hectares. And as all of us know, the dependency on groundwater is expected to increase in future due to increase in population. Based on this importance of groundwater, the government of India has envisaged a very big national project called Rajiv Gandhi National Drinking Water Mission. Next slide, please. So this is initiated by Ministry of Rural Areas and Employment, Government of India. The objective of this is to map the lithology, geomorphology, and structural characteristics of an area on 1:50,000 scale, that is a survey of India toposheet wise, and to integrate the same to locate potential groundwater prospect zones and to recommend suitable structures for groundwater recharge. In this particular project, the data used is IRS 1D List 3 of 1999 and IRS P6 satellite data of 2006. The ultimate results of this project is various hydrogeomorphological units are delineated and suitable recharge structures are proposed at drinking water affected villages. There are drinking water affected villages that are categorized as partially covered, not covered by drinking water. Like that, there are different categories by rural water supply and sanitation department has categorized these villages. So the attention is paid only on partially covered and not covered villages for this groundwater mapping is concerned. But the mapping is done for the entire country. Next slide, please. This is the flowchart of the procedures followed. We have followed IRS P6 list data of WGS 84 data mistaken. Survey of India toposheet is used, and on-screen interpretation of the satellite data using Survey of India toposheet and satellite data is used, and existing maps that are available, existing literature is also integrated, and like that 5 thematic maps are delineated, like base map, lithological map, structural map, geomorphology map, and hydrology map. Hello, Babu. Slide poinama, Babu. Hello. Hello.
Sir,
Slide kanpaledamma.
Kanipistam, sir.
Now it is visible. Thank you. So there are like that. There are 17 layers are present in this entire hydrogeomorphological map, starting from administrative boundaries, canal, drainage line features, rail, road, drainage polygon, settlement point, spring, rain gauges, wells, water resources development plans, line feature, water resources development plan, polygon features, irrigated area, lithology, structure, geomorphology, and the lithology plus geomorphology. Like that, 17 features are there in this particular area. I came to know from NRSC that no other hydrogeomorphology map in the world is having this much of information. So it's a very good information. Map has having 17 types of layers are present in this particular map, and using Survey of India digital topo sheets, administrative boundaries, canal, drainage, rail, roads, drainage polygon, settlement point, and the springs and rain gauges are delineated. And using satellite data, irrigated area, lithology, structures, geomorphology, and lithology plus geomorphology are combined. That's called LithGeom. These are prepared from using satellite data, and interactively wells, water resource development plans, water line features, water resource development plan, polygon features are delineated. Next slide, please. This is the pro forma we have prepared for field work. Whenever we go to the field, we go to taking all these pro formas for each and every feature. For geomorphology, one pro forma is there. For structural features, one pro forma is there. For collecting well information data, one pro forma is there. Just I am showing the information for collecting well data for this pro forma. Is an example I'm showing this pro forma. Next slide, please. This is the Survey of India topo sheet on 1:57 scale, 57J by 10. This represents Kamalapuram area, and you know this is river Penner, this is river Kundu, and this is river Papagni. All the three rivers are coming and joining the. Yes. All the three rivers are coming and joining near Kamalapuram, and this is the Survey of India topo sheets 57J by 10 covering Kamalapuram and its environs. Next slide, please. This is the hydrogeomorphological map of the Kamalapuram area, the same topo sheet area. This is again Penner, Kundu, and Papagni, and these are all green or pediplain moderately weathered, yellow or pediplain shallow weathered, red or hill areas. This orange color is all pediment areas. These are all water bodies. Like that, various hydrogeomorphological units are delineated using satellite data as well as the Survey of India topo sheet. Next slide, please. A very detailed legend is prepared using all these features, like this is the map unit, this is the hydrogen quality unit, and these are the well information data. So what is the aquifer parameters, what is the recharge conditions, and what is the water quality area of this particular district topo sheet, and what is the rainwater harvesting structures we are recommending, and what is their priority? Are there very high demand or medium demand or low priority? And what is the problems and potentialities in this particular topo sheet area for each and every hydrogeomorphic unit? All these problems and potentials are listed out. Like that, a very good detailed legend is given in this particular area. Next slide, please. This is again geomorphology of the Karpa district in this particular area. So what are the fluvial landforms, denudation landforms, and structural landforms all are delineated using the satellite data as well as the Survey of India topo sheet coupled with field information. Next. This is the structural map. Again, I'm showing you. So these are the structural features. The various structural features are delineated, and these are the surface water bodies present in our Karpa district. Next. This is the groundwater prospects map as a whole for the Karpa district, and just a minimized legend is given, and the color codes are given. These color codes, this blue is very good potential, green is good to moderate, and yellow is moderate to poor, and this light pink is poor, and red is negligible as far as the groundwater prospects are concerned. And this is a small legend given for this particular area, because such a big legend cannot be given for this entire district. So a small abbreviated legend is given. Next slide, please. So recently our Kadapa district is divided into two districts, YSR Kadapa district as well as Annamaya district. So this is YSR Kadapa district I'm showing you. This is the satellite mosaic of YSR Kadapa district. In this particular YSR Kadapa district, three revenue divisions are delineated, like Jammal Madugu, YSR Kadapa, and Badwel. And so in each, this is the table given. So what are the revenue divisions and what are the mandals present, and each mandal, how many villages are present, and what is the aerial extent of the villages, all is given in this particular YSR Kadpa district. This is the grand total of the number of villages, number of mandals, and total area of this particular YSR Kadpa district. Next slide, please. This is again YSR Kadpa districts, very revenue division with all mandal boundaries in detail. These are the mandal boundaries in each and every revenue division. So we are somewhere here in this Chintakamadina mandal. So this is Kadapa. So we are somewhere here. Our Yogi Vamana University is located somewhere here. Next slide, please. This is mandal map of Karpa district showing different mandals and with broad road network. Next slide, please. This is land use land cover map of this area. So using 2 season satellite data, that is Rabi season and Kharif season satellite data, this land use land cover map is prepared. And from this land use land cover map, so what is the built up land and what is the agricultural land? So within that agricultural land, what is the Rabi irrigated, Kharif irrigated, Kharif unirrigated, Rabi unirrigated, what are the double crop areas, what are the plantations, all these things are comes under agricultural category. And again, forest category. So what are the types of forest, whether degraded forest, dense forest, deciduous forest, or scrub forest, or wherever forest plantations are there, all these forest categories are delineated in these forest areas. And again, wastelands are delineated. So based on wastelands, so whether they are barren, rocky, stony waste, whether they are mining and industrial waste, whether they are scrublands, whether other scrub with scrub land with scrub, land without scrub, all these parameters are covered under wasteland categories. And other categories, what are the canals, what are the water bodies, all these some under other categories. This is the land use land cover map. Sometimes this summer data is also used for, in addition to Rabi and Kharif season data. This summer data helps to delineate plantations of this particular area. So wherever there are plantations, that means irrespective of the Rabi season and Kharif season, plantations remain 365 days per year. So what are the plants that are remaining in this other than Rabi and Kharif seasons that are included under plantations? Next. This is geology of our YSR Karpa district. This YSR Karpa district is nothing but the parliamentary constituency of YSR Kadapa. So in Kadapa district, there are 2 parliamentary constituencies. That is one Rajampet parliamentary constituency and also for Kadapa parliamentary constituency. This is the geology of the Kadapa district, right from Archeans to Precambrians, with the Golcharu quartzites, Vempalli shales and limestones. This is the Tadipatri shales and quartzites. And these are the Kambam shales and formations. All these formations are given in this particular geology map. Next slide, please. This is the small legend pertaining to that geology map. This again borrowed from Geological Survey of India, Government of India. Next slide, please. This is structural map of our Kadapa, YSR Kadapa district. This again, Chitravati, Penner, Papagni, all the 3 major rivers flowing in this particular direction. And these are the structural features: axial trace of fold, drainage parallel, faults, lineaments, ridge parallel, scar parallel. All these different structural features are delineated in this particular district. Next. Next. This again geomorphology map of Kadapa district. As I said, these are all fluvial landforms, degradation landforms, and structural landforms are delineated using Survey of India topo sheet and satellite data coupled with field survey. Next slide, please. This is again hydrogeomorphology map. This hydrogeomorphology map is a combination of mainly 3 layers: geology, geomorphology, and structure, and hydrology map. This is a combination of 4 layers: geology, geomorphology, structure, and hydrology map. So other than the maps, there are different layers are there, but these are the main components of this particular hydrogeomorphology map or groundwater prospects map. Next slide. This is the water quality map. So this is again carried out under Rajiv Gandhi Drinking Water Mission project phase 4. Under phase 4, this project was carried out. There are 9 chemical parameters are taken, that are pH, total dissolved solids, and total hardness, alkalinity, fluoride, chloride, iron, nitrate, and sulfate. These 9 chemical parameters are taken. This chemical analysis data for drinking water or groundwater is taken from Rural Water Supply and Sanitation Department, State Groundwater Department, as well as the Central Groundwater Board, CGWB. From these, there are 3 organizations. This groundwater chemical analysis data is collected for both pre-monsoon and post-monsoon, and a map is prepared like this. This is the legend of this particular map. So you can read the legend carefully. And these are the areas that are potable, non-potable, based on Bureau of Indian Standards. This map is categorized as potable, non-potable, like that. All these categories are given like this. Next slide, please. This is the satellite view of our Annamaya district with the revenue divisions. These 3 revenue divisions are there in this particular district again. This is Madanapalli, this is Raichoti, and this is Rajampet. 3 revenue divisions are given, and these are the 3 revenue divisions, and these are the mandals present in each and every revenue division, and these are the villages present in each and every division, and this is the aerial extent of the each and every village, and this is the total. Next slide, please. This is the, again, drainage map. This is the Somsila backwaters of Somsila reservoir. This is the Penne River. This is Annamaya project. This is located near Rajampet, and these are the small tanks, and these are the drainage present in this particular district. And this represents also again, this is Rajampeta parliamentary constituency. Next slide, please. This is again transport network. As I said, these are all mostly Panchayati Raj nodes and roads and R&B roads. And this is a
స్క్రీన్షాట్ వస్తుందా
నేను సెల్లులో తీసుకున్నాను.
మీ సెల్లో తీసుకున్నా నాకు పంపి
this is Panchayati Raj roads. And next slide, please. This is again revenue divisions of our, as I said, these are the mandals. These are the 3 revenue divisions: Madanapalli, Raichoti, and Rajampet revenue divisions with mandals. And this is the information about revenue divisions and mandals present in each and every division, villages present in each and every region, and area of those villages here given. Next slide, please. This again same mandal map with different colors are given. Next slide. Next slide, please. This is again slope map using a digital elevation model. This slope map is derived, and these are different slope categories are given from nearly level to very steep sloping. 7 categories are given in this particular area. All the 7 categories are present in this particular study area. Next. As I said, this is the land use map. 2 season satellite data is Rabi and Kharif season data is key again. Again, agricultural land, built up area, agricultural lands, forest lands, wastelands, and water bodies, and all these parameters are delineated using this particular 2 season satellite data. Next slide. This is the wasteland map of the area. So wastelands are the areas where there is no productive use, where the lands which are not fit for agriculture. These areas are called wasteland maps. So wasteland maps are nothing but this barren rocky stony waste, salt affected lands, sandy areas, scrub land with the dense scrub lands open,
So all these categories come under, at all these lands come under wasteland category. They are not fit for any agricultural use. This is the wasteland distribution in our Rajampeta, in this parliamentary constituency or Annavaya district. Next slide. This is again land degradation map. Land is degraded because of various chemical and physical parameters. So what are the lands that are degraded? What are the degraded lands we call? So that lands that are subjected to sheet erosion, moderate sheet erosion, severe sheet erosion, water sheet erosion. So the along the stream courses, there are rills are formed or gullies are formed. All this water erosion due to rills, water erosion due to gullies, and due to alkaline soils, there are sodic slight, sodic moderate, sodic severe, and saline saline water bodies, saline lands are also there, sodic lands are also there. All this comes under land that are degraded lands. So mining areas, are all mining dumps, open cast mines. These are all land under degraded lands category. They all come under degraded lands category. Next slide, please. This is the, so based on the drought situation, for each and every month, the government of India has recommended certain watersheds. So this red color watersheds that are taken up during 2009 and 10, this color, orange color has taken 10 and 11. This green color watersheds are taken from 2011 and 12. So blue color area watersheds are taken from 2012-13, and this violet color is taken from 2014-15. Like this, these are the watersheds that are present in the entire Annamaya district and under different years. These are all part of the watershed development program. So we have delineated all the watersheds in this particular district. Next slide. Again, as I said, this is a geology map of the for Rajampet parliamentary constituency or Annavaya district. This is all granitic gneiss, granite, and this is a part of the Kadapa basin. Next slide, please. This is the brief legend given for the entire geology map. Next slide, please. This is again geomorphology map. As I said, these are all fluvial lands, denudation lands, and also structural lands, structural landforms, fluvial landforms, and denudation landforms. Fluvial landforms include floodplain, channel bars, valleys, valley fills, structural valleys, whereas denudation landforms include pediplain moderately weathered, pediplain shallow weathered, buried pediplain, pediments, residual hills, and structural landforms include, these are all structural hills comes under structural landforms category. Next slide, please. This is again structural map of the area. These are all granitic terrain. You see a number of red color the dikes cutting across this granitic terrain. This grand Archean formations, and this is all Kadapa basin. These are all only faults, folds, lineaments are present in this. In addition to faults, folds, lineaments, in this area, dikes are also delineated. Next slide, please. This is again, I told you, the hydrogeomorphologic map or groundwater prospects map. And this is the small legend given. Blue color indicates very good prospects, and green color indicates good to moderate. Yellow color indicates moderate to poor. Pink color indicates poor, and red color indicates negligible groundwater prospects. This is the legend given for this particular area. Next slide, please. Again, this is the same groundwater quality map. Under Rajiv Gandhi Phase 4, we have taken this project for 9 chemical parameters taken from State Groundwater Department, Rural Water Supply and Sanitation Department, and also Central Groundwater Board. And this is the legend given for each and every mapping unit. ఏమండి This is the groundwater quality map. Next slide, please. Like we have already prepared the groundwater prospect map. For example, you can derive any area out of that particular map through a GIS technology. This is the hydrogeomorphology map of Lingala Mandal, Kadapa district. As an example, we have taken it out for Lingala Mandal, and these are the units taken. Next slide, please. This is the legend given for this is the floodplain shallow. This is buried peatplain moderately weathered in Tadipatri shales, and this is the valleys developed in Vempalli dolomites, and this is the pediment in basic intrusives, and this is the structural hills of Vempalli quartzite, and this is the structural hill of Gulcheru quartzite. Like that, for the entire Lingala Mandal, a detailed legend is prepared, and we have presented it here in the form of a groundwater prospects. And these are the groundwater prospects for each and every mapping unit. What are the groundwater prospects? Whether good, moderate to good, moderate, poor, or negligible. These are the groundwater prospects are given in this particular legend. Next slide, please. Again, as I told you, we can clip any map through GIS. That is Lingala Mandal. This is only for Lingala village. We have taken this particular village. In this particular Lingala village, only two geomorphic units are there. Only that is a structural hill and buried peatplain moderately weathered. This is yellow and red. This is Igu Lingala, Digu Lingala. There are two Lingala villages in Lingala village, and this is the two geomorphic units. This is a water body present in this very close to this Lingala village, and this is the small legend given for these two units. And this is the Lingala village hydrogeomorphology map or groundwater prospects map. Next slide, please. So I'll show you some of the field photographs of this particular we have collected during field work. This is the fluvial landforms, and this is our Penneru River near Siddhautam. This is the Siddhautam Fort we are seeing here, and this is the Penneru River. Next slide, please. This is the valley field supporting good agricultural activity. So I am standing on a hill, and I have taken this photograph from here this way, and this is the hill, and this is the hill I am standing, and in between these two hills, there is a very small valley is present with very good agricultural activity, and very good greenery is there, and in this particular valley field. Next slide, please. They have constructed a well in this particular valley fill area. You can see the fine texture of clay and fine texture of silt in this particular area. There are no boulders at all. There are no rocks at all in this particular well excavation, and only silt and clay are excavated. And these particular wells in this particular valley fills gives very good yields. Next slide. This is again a floodplain near Gandi Anjaneya Swami temple near Vempalli. This is Papagni River, and very close to this Papagni River, this is a floodplain with very good agricultural activity. Next slide, please. This is the cross section of the floodplain, and there is adjacent one river is there. And just when we are passing through this causeway, there is a very big, good cross section is there, showing the cross section of the floodplain. Next slide. Next slide, please. There is a good agricultural activity in the floodplain area with very good groundwater yields, and paddy is being irrigated in this floodplain area. This very good with very good groundwater yields, and paddy is being irrigated in the floodplain area. Next slide, please. Next slide. This we will go to now. Fluvial landforms are completed. Now we'll go to denudation landforms. Next slide. This is the pediplain shallow weathered area. So what is the shallow weathered area? Shallow weathering means 0 to 10 meters. If the weathering is 0 to 10 meters, they are called shallow weathered areas. If the weathering is 10 to 20 meters, they are moderately weathered areas. If the weathering is more than 20 meters, they are called deep weathered areas. So now this is a shallow, periplain shallow weathered, supporting some good floriculture. Next slide. This again the periplain shallow weathered near Ramapuram, our Yogi Vemana University area. This is again showing floriculture. This again, in this particular area, the weathering is 0 to 10%, 10 meters only. Next slide. Again, the periplain near Rajupalayam, near Rajampet, is all good mango plantations are there, mango orchards are there, and these are all red soils area. So in this area also, the depth of weathering is 0 to 10 meters. Next. This is again periplain moderately weathered area. So in this particular periplain moderately weathered area, that is the depth of weathering is more than 10 meters to less than 20 meters. So in this particular area, when compared to shallow weathered area, the moderately weathered periplain has very good groundwater prospects. So that is why they are growing paddy in this particular moderately weathered periplain areas. Whereas you can see very dry crops, where are some horticultural crops in shallow weathered periplain area. Whereas in moderately weathered periplain area, we are seeing very intensive agriculture activity. Next. This is a part of the residual denudation landforms. It's a residual hill near Vempalli. It's a small hill. Next. So again, this residual hill. In the foreground is a periplain, shallow weathered periplain is there. And this again, residual hill is there near Sambepalli. Next. So it is again a residual hill. In this, a series of dolerite dikes. This is one dike, this is another dike, and this another dike. 3 dikes are cutting across these residual hills for tens of kilometers. These dolerite dikes are noticed in this particular area. It's a granitic hill, residual hill, cut across by dolerite dikes. Next. Again, this is a residual mound near Mopuru temple, near Pulivandala. It's a residual mound. Again, this is again shallow weathered periplain. This is a residual mound. It's a part of it's both are under denudational categories. Next. Next, please. This is a pediment. It's a rocky pediment, rock cut surface exposed in the field. It's also part of the denudational landform. Next. This is the cross section of the well showing moderately weathered periplain. You can see the depth of weathering is more than 10 meters. So we have categorized this particular well under moderately weathered periplain category. So whenever as part of our field verification, we have come across this well and taken this photograph cross section of the well, which is the weathering is more than 10 meters in this particular area. That is, it is in the moderately weathered periplain with very good yields. Open well. Next. The cross section of this particular well showing shallow weathered periplain. These are all hard, massive, shallow weathered rocks are there. So it's a shallow weathered periplain with 0 to 10 meters of weathering. So with less groundwater prospects. Next. So structural landforms are concerned. This is the photograph taken on the way to Pulivandala to Kadri Ghat section. This is the very good fault is there. In this, you can see this is the fault plane, and this is the very good fault is there. And this is the photograph taken from Pulivandala to Kadri Ghat Road. And these are the, we'll go now see some structural landforms. Next slide, please. So as you know, this is a beautiful gorge cut across by our river Pennar in this quartzites. And it's a very it's a area of very good scenic beauty. It's a gorge. Next slide, please. This cluster you can see in this particular gorge areas. So you can, if you see the cluster, you can see one is leeward side and another is dipward side. One is steep sloping area, and the other side of the cluster is gently sloping area. So such landforms are called clusters. And so this is the cluster near Gandikota, near this Gandikota gorge. Next slide, please. This again a linear ridge near Kambam in Prakasham districts. As part of the wind energy program, we have carried out a very big project for NetCap. We have identified wind energy stations using remote sensing and GIS techniques. So during our field work in Prakasham districts, we have climbed this linear ridge, and we have recommended one wind energy site in this particular linear ridge. It's a quadrate ridge in a linear shape. It's called, it's a linear ridge near Kambam, Prakasham district. Next slide, please. This again is escarpment. This is sharp thrust is there. You can see sharp thrust is there. It's a quartzite near Udipalpaya. This is a very good escarpment is there. You can see. It's again a structural hill. Next. Next slide, please. Babu, slide పోయిందమ్మా బాబు. హలో
సార్ సార్ పవర్ కట్ అయింది సార్ ఇక్కడ. జస్ట్ 2 minutes సార్.
రైట్ రైట్.
Sir,
సార్
my name is Rahmat Basha,
చెప్పండి.
retired statistician, groundwater department.
ఓ సార్, గ్రౌండ్ వాటర్, వెరీ గుడ్.
సార్, మీరు సపరేట్ గా లింగాల మండలనే ఇది చూపించారు అలా.
ఎగ్జాంపుల్ అండి అంతే.
ఎగ్జాంపుల్ అంటే అదర్ మండల్స్ గురించి కంపారిజన్ చేసినారా ఏమన్నా?
అదర్ మండల్స్ అంటే మనకు అవసరమైతే మనం చేస్తాం డెఫినెట్ గా. when it is required we'll do it, otherwise we don't do it. We'll generally map the area and give it to the department. మన స్టేట్ మన గ్రౌండ్ వాటర్ డిపార్ట్మెంట్ కు మన ఆల్ ద మ్యాప్స్ మేము ఇచ్చామండి. అట్లా వాళ్ళు ఏదైనా చేయమని ఏదైనా కావాల్సిన అవసరం ఉంటుంది, ఏదైనా చేయండి అంటే డెఫినెట్ గా మేము చేసి వాళ్ళు మా రిజల్ట్స్ మేము ఇస్తాము. అదర్వైజ్ వీ డోంట్ కంపేర్ ప్రతి ఈచ్ అండ్ ఎవరీ మండల్ కంపేర్ చేసి ఇవ్వం. అవర్ ఆబ్జెక్టివ్ ఈస్ ఓన్లీ టు మ్యాప్ ద ఏరియా.
సార్, ఎందుకంటే లింగాల మండలంలో నా అభిప్రాయం ఏమంటే ఎక్కువ డీప్ లో ఉంటాయి వాటర్ అనేసి.
ఓకే, అందుకే బెడ్ ప్లేన్, షాలో వెదర్డ్, స్ట్రక్చరల్ హిల్స్ ఆ రెండు యూనిట్లు వచ్చాయి మనకు లింగాల విలేజ్ లోను. మండల్లో కొద్దిగా చాలా యూనిట్స్ వచ్చాయి అనుకోండి.
ఎందుకంటే అక్కడ పార్నపల్లి రిజర్వాయర్ ఉండదు కదా, దాని ఇన్ఫ్లుయెన్స్ ఏమి ఉండదు అక్కడ వాటర్ లెవెల్ కు అనేసి.
అయ్యో తప్పనిసరిగా రిజర్వాయర్ ఇన్ఫ్లుయెన్స్ 100% ఉంటుంది నియర్ బై. దాంట్లో బేస్డ్ ఆన్ ద స్ట్రక్చర్స్ ఈ దాంట్లో రిజర్వాయర్ ఇన్ఫ్లుయెన్స్ ఉంటుందండి, బాగుంటుంది.
అదే అంటే నియర్లీ అది 25-30 కిలోమీటర్స్ దూరంలో ఉన్నది, అంత దూరం వరకు ఇన్ఫ్లుయెన్స్ ఉంటుందా అని.
ఇన్ఫ్లుయెన్స్ అంటే అదే చెప్తున్నా కదా, నేను చెప్తున్నా ఆ సబ్జెక్ట్ కూడా వస్తాను ఇప్పుడు నేను. హౌ టు రికమెండ్ రెయిన్ వాటర్ హార్వెస్టింగ్ స్ట్రక్చర్స్ అనే దానికి వస్తాను. ఆ రెయిన్ వాటర్ హార్వెస్టింగ్ స్ట్రక్చర్స్ లో అక్కడ ఫాల్ట్స్, ఫోల్డ్స్, ఫ్రాక్చర్స్ కనుక ఉంటే ఆ ఏరియాలో ఆ రిజర్వాయర్ నుంచి ఆ లింగాల మండలం వరకు పెద్ద పెద్ద ఫాల్ట్స్, ఫ్రాక్చర్స్ కనుక ఉంటే డెఫినెట్ గా ఆ ఫాల్ట్స్, ఆ ఫ్రాక్చర్స్ ద్వారా వాటర్ సీపేజ్ అయ్యి అక్కడ వాటర్ రిసోర్సెస్ డెవలప్ అయ్యే ఛాన్సెస్ ఉన్నాయండి. బట్ అక్కడ ఎంత మాత్రం అక్కడ ఫాల్ట్స్, ఫోల్డ్స్, ఫ్రాక్చర్స్ ఉన్నాయో మనం చూసుకోవాలి అక్కడ. అది అది అంతే తప్ప డెఫినెట్ గా అంత పెద్ద రిజర్వాయర్ అంత ఉన్నప్పుడు దాని యొక్క ఇన్ఫ్లుయెన్స్ ఏరియా మీద బ్రహ్మాండంగా ఉంటుంది.
సరే సార్, థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. సిద్ధిరాజు బాబు, సిద్ధిరాజు
సార్. హలో సార్.
ఏమా మన దగ్గర జనరేటర్ లేదా?
లేదు సార్, ఇక్కడ ప్రాబ్లం ఉంది. ఒక 2 minutes సార్, we will resolve this.
సరే సరే, ఓకే ఓకే,
Sorry for that.
నో ప్రాబ్లం, నో ప్రాబ్లం. మేడం, నేనేమన్నా టైం ఎక్కువ తీసుకుంటున్నానా? టైం త్వరగా ముగించమంటారా? ఇంకొక స్పీకర్ ఉన్నారని చెప్తున్నారు కదా.
You have another 10-15 minutes, no issue, sir. Another speaker will be joining around 11:30 or something like that. Meanwhile, we'll try to resolve the power issue, sir.
సరే సరే, ఓకే మేడం.
Okay, one second.
హలో సార్, గుడ్ మార్నింగ్ సార్.
గుడ్ మార్నింగ్ అండి.
సార్, నా పేరు శేక్షవల్లి సార్.
చెప్పండి
సార్, గ్రౌండ్ వాటర్ ఎక్స్ప్లోరేషన్స్ కి ఏ మెథడ్ అయితే బెటర్ ఉంటుంది సార్?
అంటే
రెసిస్టివిటీ మెథడ్ వాడుతున్నారు కదా సార్?
అంటే మేము అంతా ఓల్డ్ టైమర్స్ అండి. మేమంతా రెసిస్టివిటీ మీటర్స్ యూస్ చేసామంతా. ఎలక్ట్రోడ్స్ అంతా పాతే రెసిస్టివిటీ మీటర్సే పెట్టి చేసాము. ఈ మధ్య కొత్త కొత్త టెక్నాలజీస్ అన్ని వస్తున్నాయి. గ్రౌండ్ వాటర్ ఎక్స్ప్లోరేషన్ కు అంతా చాలా ఫాస్ట్ గా, చాలా లార్జ్ ఏరియాస్ విత్ ఇన్ ద నో టైం కవర్ చేస్తున్నారు. అండ్ వెరీ గుడ్ ఇన్ఫర్మేషన్ కూడా ఇస్తున్నాయి అవి. అండ్ చాలా మనము పాత మెథడ్స్ లో ఎలక్ట్రోడ్స్ ఎంత వరకు తీసుకుపోతే భూమిలోకి మనం అంత లోపలికి మనము కరెంటు పాస్ చేసి అంత డెప్త్ వరకే మనము అనాలిసిస్ చేసేవాళ్ళము. ఇప్పుడు ఈ కొత్త మెథడ్స్ వల్ల చాలా చాలా కొద్దిగా మోర్ దాన్ 500-600 ఫీట్ కూడా అది డెప్త్కి వెళ్ళి ఈజీగా వాట్ ఆర్ ద aquifer parameters, what are the faults, what are the fractures, what is the weathering depth అన్ని చాలా కొత్త కొత్త మిషన్స్ అన్ని బాగా చెప్తున్నాయండి. అది నాకు అంత ఐడియా లేదు, కొత్త మిషనరీ కొత్త ఎక్విప్మెంట్ ఏమొచ్చిందో ఏమో అది. బట్ మేమంతా పాత వాళ్ళం కాబట్టి మాకు ఈ ఎలక్ట్రోడ్ జియోఫిజికల్ సర్వేసే నేను చేశాను కాబట్టి నాకు దాంట్లో ఇంతో అంత పరిచయం ఉంది కాబట్టి నేను చెప్పగలుగుతాను. కొత్త టెక్నాలజీ వచ్చింది, నాకు అంత ఐడియా లేదు కొత్త టెక్నాలజీ గురించి.
కొన్ని ఉన్నాయి సార్ కొత్తవి ఎక్విప్మెంట్స్, అవి అక్యురసీ కరెక్ట్ గా వస్తాయి రావని ఐడియా తెలియదు.
ఏమండి ఏమండి ఏమండి
ఒకటి PQWT అని ఒకటి సార్.
ఎస్ PKWT ఉంది. అవును, చూశాను, మిషన్ కూడా చూశాను నేను. ఎస్ యు ఆర్ రైట్, ఉంది. అవును, చూశాను, మిషన్ చూశాను. బట్ నేను సర్వే చేయలేదు, ఆ మిషన్ తో నేను ఎప్పుడు సర్వే చేయలేదు. ఆ మిషన్ చూశాను, అయితే నా కొలీగ్ ఒక అతని దగ్గర ఉంటే అది నేను చూశాను, ఆ మిషన్ చూశాను. బట్ దాంతో చాలా మంచి ఇన్ఫర్మేషన్ వస్తుంది అని విన్నానే తప్ప నేను ఎప్పుడు దాంతో వర్క్ చేయలేదండి.
అక్యురసీ ఎంతవరకు కరెక్ట్ రాదు సార్?
చెప్తున్నా కదా,
రెసిస్టివిటీ మీటర్ తో పోల్చుకుంటే
అదే బాగుంటుంది అంటారు. రెసిస్టివిటీ మీటర్ తో పోల్చుకుంటే మీరు చెప్పిన ఎక్విప్మెంటే చాలా యాక్యురేట్ వెన్ కంపేర్ టు రెసిస్టివిటీ మీటర్ అని చెప్తారు. బట్ నేను ఎప్పుడు పోల్చి చూడలేదు. రెసిస్టివిటీ మీటర్ ఒకటే ఏరియాలో వచ్చేసి అదే మీటర్ తో ఒకటే ఏరియాలో వచ్చేసి ఎలా వస్తాయి గ్రౌండ్ వాటర్ రిజల్ట్స్, సర్వే రిజల్ట్స్ అనేది
కొంచెం డిఫరెంట్ వస్తుంది అన్నారు సార్.
ఏమండి
ఈ రెండు PQWT విత్ రెసిస్టివిటీ మీటర్ క్రాస్ సెక్షన్ చేస్తే కొంచెం వేరియేషన్ వచ్చింది అన్నారు సార్.
వస్తుంది, డెఫినెట్ గా వేరియేషన్ అంటూ ఉంటుంది. బట్ ఎంత వేరియేషన్, విచ్ ఈస్ బెటర్, 10%, 20%, 30% ఎంత అనేది నేను ఎప్పుడు అంత కంపేర్ చేసి చూడలేదు, నాకు అంత ఐడియా లేదు అది. బట్ దట్ ఈస్ మోర్ సోఫిస్టికేటెడ్ దాన్ జియోఫిజికల్ సర్వే రెసిస్టివిటీ మీటర్. 100% దట్స్ మోర్ సోఫిస్టికేటెడ్. ఆ మోర్ ఇన్ఫర్మేషన్ కూడా వస్తుందంట దాంట్లో వెన్ కంపేర్ టు రెసిస్టివిటీ మీటర్స్ తో. వర్టికల్ సౌండింగ్స్ తీస్తే దానికన్నా దాంట్లో మంచి ఇన్ఫర్మేషన్ వస్తుంది అని విన్నాను నేను. అంటే మాది మోస్ట్లీ రిమోట్ సెన్సింగ్ GIS టెక్నిక్స్ అంతా మేమంతా ల్యాబ్ లో కూర్చొని ఎక్కువ చేస్తాము. ఫీల్డ్ కూడా వెళ్తాము మేము, డెఫినెట్ గా ఫీల్డ్ సర్వేస్ కూడా చేసి ఫీల్డ్ ఇన్ఫర్మేషన్ కూడా గ్యాదర్ చేసి అంతా బాగా చేస్తాము. బట్ మేము యాక్చువల్ గా గ్రౌండ్ వాటర్ ప్రాస్పెక్ట్స్ మ్యాపింగ్, గ్రౌండ్ వాటర్ సర్వే చేసి మేము ఎవరికి రిజల్ట్స్ ఇవ్వము. మేము ఓన్లీ మ్యాపింగ్ వరకే మేము చేసేది. బట్ అవుట్ ఆఫ్ మై ఇంట్రెస్ట్ నేను చాలా మార్లు ఈ ఎస్పెషల్లీ అనంతపురం జిల్లాలో ఈ పుట్టపర్తి ఆ ఏరియాలో చాలా రెసిస్టివిటీ సర్వీస్ చేసి దాంతో కొద్దిగా నేను చేశాను. సమ్వేర్ ఐ వర్క్ ఇన్, చెప్తున్నా కదా, 96-98లో నేను ఐ వర్క్ ఇన్ అనంతపూర్ డిస్ట్రిక్ట్ ఫీల్డ్ ఇన్ఛార్జ్, ఫీల్డ్ ఆఫీస్, అనంతపూర్ డిస్ట్రిక్ట్ ఫీల్డ్ ఆఫీస్ కి ఇన్ఛార్జ్ గా నేను పనిచేశాను 1996-98లో. అప్పుడు వీ హ్యావ్ క్యారీడ్ అవుట్ చాలా ఏరియాస్ లో రెసిస్టివిటీ సర్వేస్ చేసాము. ఫర్ గ్రౌండ్ వాటర్ సర్వేస్, వర్టికల్ ఎలక్ట్రికల్ సౌండింగ్స్ తీసాము. పుట్టపర్తి చుట్టుపక్కల ఏరియాస్ లో అంతా మన సత్సాయి బాబా వాళ్ళ ట్రస్ట్ కోసమని అప్పుడు నేను చేశాను. అప్పటికి ఆ కాలంలో ఇంకా మీరు చెప్పిన ఇప్పుడు ఎక్విప్మెంట్ అవన్నీ లేవు అప్పుడు. తర్వాత ఇప్పుడు కొత్తగా వచ్చాయి, ఫర్ ద లాస్ట్ 10 years నుంచి ఇవి వచ్చినాయి అనుకుంటాను. ఇవి మీరు చెప్పిన ఎక్విప్మెంట్స్ అంతా కొద్దిగా సోఫిస్టికేటెడ్ అంతా. మా ఫ్రెండ్ కూడా చేస్తున్నాడు, అతను చేస్తున్నప్పుడు నేను వెళ్ళి చూశాను అతనితో. బట్ అదే ఏరియాలో రెసిస్టివిటీ సర్వే చేసి కంపేర్ చేయలేదు నేను ఎప్పుడు.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ
సార్. అహ్మద్ బాషా అనేది ఏమనుకోకుండా ఒక ఇన్ఫర్మేషన్ సార్.
చెప్పండి
సార్. ఇప్పుడు మేము డిపార్ట్మెంట్ లో ఉండేటప్పుడు నెదర్లాండ్స్ నుంచి ఫారినర్స్ వచ్చినారు డిప్యుటేషన్, అంటే ఏదో మాకు ట్రైనింగ్ ఇచ్చేదానికి. తర్వాత CGW వాళ్ళు కూడా నెదర్లాండ్స్ అనే దానికి ట్రైనింగ్ పోతూ ఉంటారు ఎక్కువగా. నెదర్లాండ్స్ అంటే ఇంపార్టెన్స్ ఏమున్నది సార్ జియాలజిస్టులకు అక్కడ?
జియాలజిస్టులు అక్కడ ITC అని ఒక చాలా రిమోట్ సెన్సింగ్ GPS దాంట్లో సంబంధించిన ఒక వరల్డ్ ఫేమస్ ఇన్స్టిట్యూట్ ఉందండి. ITC అంటారు దాన్ని, ITC నెదర్లాండ్స్ అని. దట్స్ ఎ వెరీ ఫేమస్ రిమోట్ సెన్సింగ్ డిజిటల్ ఇమేజ్ ప్రాసెసింగ్ GIS ఇన్స్టిట్యూట్. అది చాలా ఫేమస్ ఇన్స్టిట్యూట్ ప్రపంచంలోనే, అది నెదర్లాండ్స్ లో ఉంది. ఆ ఇన్స్టిట్యూట్ కు ట్రైనింగ్ అంతా మన వాళ్ళు వెళ్తుంటారు. నెదర్లాండ్స్ గవర్నమెంట్ కూడా ఆ ఇన్స్టిట్యూట్ నుంచి ప్రాజెక్ట్స్ కూడా ఇస్తుంది. మా అబ్స్ట్రాక్ట్ కూడా ఒక 4-5 ప్రాజెక్ట్స్ డ్యూరింగ్ 90s లో మనం కంబైన్డ్ ఆంధ్రప్రదేశ్ స్టేట్ ఉన్నప్పుడు ఫ్లోరైడ్ అఫెక్టెడ్ ఏరియాస్ కి సంబంధించి కానీ, గ్రౌండ్ వాటర్ ప్రాస్పెక్ట్ సంబంధించి కానీ, నల్గొండ ప్రాంతాల్లో అంతా నెదర్లాండ్స్ అసిస్టెడ్ ప్రోగ్రామ్ కింద ప్రాజెక్ట్స్ చేశాము. ఆ పర్టికులర్ ఐటీసీ ఇన్స్టిట్యూట్ కు ట్రైనింగ్ కు మన గ్రౌండ్ వాటర్ డిపార్ట్మెంట్ నుంచి కానీ, సెంట్రల్ గ్రౌండ్ వాటర్ బోర్డు నుంచి కానీ వెళ్తుంటారండి.
సార్ మీరు నల్గొండలో ఉండేటప్పుడు చంద్రశేఖర్ గారు అనేసి ఉన్నారు, మీరు మీట్ అయినారా? డిప్యూటీ డైరెక్టర్ గ్రౌండ్ వాటర్.
ఎంవి చంద్రశేఖర్.
ఎస్ సార్.
తెలుసండి.
ఆయన బెస్ట్ జియాలజిస్ట్ సార్. ఆయన పర్వాలేదు, సీనియర్ మోస్ట్ మా డిపార్ట్మెంట్ లో.
మీ గ్రౌండ్ వాటర్ డిపార్ట్మెంట్ తో నాకు చాలా చాలా పరిచయాలు ఉన్నాయండి. రైట్ ఫ్రమ్ చాలా పెద్ద సీనియర్స్ నుంచి, మన బిఎన్ ప్రసాద్ గారి దగ్గర నుంచి, అంతమంది సీనియర్స్ నుంచి నాకు చాలా మంది బాగా తెలుసండి గ్రౌండ్ వాటర్ లో.
ఆయన 73-74 లో ఏహెచ్జిగా నాకు ఇన్ఛార్జ్ గా ఉన్నారు సార్ అనంతపురంలో. నేను 10 years పనిచేశాను అనంతపురంలో.
ఓకే ఓకే ఓకే.
మళ్ళీ తర్వాత వచ్చేసి కడప, కర్నూలు చేశాను. తర్వాత రిటైర్డ్ అయ్యాను. బట్ నేను బిఎస్సి జియాలజీ రీసెంట్ గానే 2 years బ్యాక్ నేను ఎంఎస్సి జియాలజీ కూడా చేశాను ఇక్కడ మన వైవిలో.
వెరీ గుడ్ వెరీ గుడ్ వెరీ గుడ్.
అక్కడ వీళ్ళు ప్రొఫెసర్లు కూడా చాలా సీనియర్ మోస్ట్, బాగా ఇది కోచింగ్ బాగా ఇస్తారు సార్ వాళ్ళంతా చెప్పడంలో కూడా. కాబట్టి వైవి నేను లైక్ చేసి 2 years అక్కడ కంప్లీట్ చేశాను సార్. ఇప్పుడు
వెంకటరామరెడ్డి గారి పరిచయమా మీకు? పాత ఆయన
నాకు క్లోజ్ సార్. ఆయన నా డిప్యూటీ డైరెక్టర్. ఆయన కర్నూలు అండ్ కడపలో ఆయన రిటైర్డ్ అయినాడు. చాలా మోస్ట్. ఇప్పుడు కూడా ఉదయమే మాట్లాడినాను ఆయనతో.
వెంకటరామరెడ్డి గారు
ఆయన దగ్గర పని చేయాలంటే చాలా సిన్సియర్ గా ఉండాలి సార్ ఎవరైనా కానీ. ఆయన వస్తున్నాడంటే కొంతమంది సెలవు పెట్టేసి వెళ్ళిపోయామనుకున్నారు సార్. నిన్ననే మాట్లాడినాను. నాకు చాలా క్లోజ్ సార్ ఆయన, శిష్యుడిని నేను.
ఆయన అనంతపూర్లో కూడా పనిచేశారు. నాకు చాలా బాగా పరిచయం అయింది. నేను బిఎస్సి చదివేటప్పటి నుంచి నాకు ఆయన పరిచయం, వెంకటరామరెడ్డి సార్.
మీరు ఎక్కడ సార్ బిఎస్సి?
కడప ఆర్ట్స్ కాలేజ్ అండి.
Sir, sorry to interrupt you.
Sir, madam.
I think the power is back, sir. Please, could you?
Sir, right. I'll start my lecture.
Yeah.
Okay.
Thank you, sir.
Right.
Thank you, sir.
Basha garu mali maatladam. Okay.
Very good, sir. Thank you, sir.
Right. Thank you. So this is again ridge, and ridge is very well seen in this particular granitic terrain. This is near Lakiredipalli. Next slide, please. Next slide. This is a very big structural hills. This I have taken near Penchalkona, near Chitwell, near Rapur, Penchalkona. These are all Byronkonda quarters. So very good waterfalls are also there. You can see small waterfalls coming in this particular area. And this is the Byronkonda quarters. This is structural hills near Penchalkona. Next slide, please. This is again structural hill near Chitwell. Next slide, please. This is a dike. What is a dike? It is nothing but a fracture-filled body. It is a discordant body. It's a discordant body. It's a fracture-filled body. Next slide, please. This is also a dike near Galibido. Next slide, please. So this is a Vemula Barrett mining area. This is a underground snow white barrett is area. This underground area. This is my PhD area. I worked on Vemula Barrettis and also Mangampeta Barrettis. Like out of my interest, I am showing you this field photograph. Next slide, please. This is Mangampeta satellite image of Mangampeta Barrett mine area. So I for my PhD, I worked on both Vemula Barrettis and Mangampeta Barrettis for my PhD in Tirupati Venkateswara University. This is the Mangampeta mining area. Next slide, please. So I'll rush through these photographs. This is the dam across Pennar near Mailavaram. Next slide, please. This is again Veerabrahmendra Swami Reservoir. near Badvel. These are all structural hills. This is the reservoir, Potla Veerabrahmanandra Swami Reservoir. Next slide, please. Next slide. Slide పోయిందమ్మా సిద్ధిరాజు.
హలో సార్.
పోయింది ఆ స్లైడ్ పోయింది రావడం లేదు.
Sir, I request you, sir, please share. I was given to co-host you, sir. You can share your PPT through share option. If you don't mind.
మీకు రాలేదా?
సార్ ఇక్కడ పవర్ కట్ అయిపోతుంది సార్. ఇక్కడ పవర్ సబ్స్టేషన్ ప్రాబ్లం ఉందంట.
నాకు తెలియకే నేను పవర్ మీకు పంపించాను.
ఓకే సార్.
ఎట్లా చేయాలో నాకు తెలియదమ్మా. ఇది అందువల్లే నేను మీకు ముందుగానే నా ప్రెజెంటేషన్ పంపించాను.
बात करना नहीं वो म्यूट को उठा भाई हमने बात करे उसे नहीं अच्छा बात करा
ఎట్లా చెప్పావు? స్టార్ట్ వీడియో షేర్ 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 అన్నా కదా.
वो बूढ़ा है मैं भी छोटा दिख रहा है कहाँ है
రాజా సిద్ధిరాజు
సార్
ఎట్లా చేయమంటావు? షేర్ పోయిన తర్వాత ఎక్కడ పోయి పొమ్మంటా సర్చా?
సార్ ఫస్ట్ మీ పవర్ పాయింట్ ఆన్ చేయండి సార్.
అదే నా పవర్ పాయింట్ నేను షేర్ లోకి పోతున్నాను. షేర్ లో ఏం చేయాలా?
సార్ పవర్ పాయింట్ ఓపెన్ చేసిన తర్వాత షేర్ లోకి వెళ్ళి జస్ట్ పవర్ పాయింట్ ఉంటుంది. జస్ట్ పవర్ పాయింట్ మీద క్లిక్ చేస్తే సరిపోతుంది సార్.
ఇప్పుడు నా పవర్ పాయింట్ ఓపెన్ చేయమంటావా?
చేయండి సార్.
చేస్తాను, ఒక్క నిమిషం.
హలో సార్.
వస్తున్నా, ఒక్క నిమిషం.
Sir, I just connected to Wi-Fi. Now it is okay, na sir, for you?
నేను ఒకటి మినిమైజ్ చేశాను. ఓకే 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 ఎట్లా చేయాలి?
Now it is coming, sir.
మీకు పవర్ వచ్చిందా?
Sir.
ఒక్క నిమిషం.
Yes, sir.
బాబు నేను స్టార్ట్ చేయనా?
Sir. Carry on, sir.
Okay, this is the Gandikota Reservoir. Sorry for the interruption. Next slide, please. ఫాస్ట్ గా చెప్పేస్తాను బాబు, కొద్దిగా టైం కూడా లేదు. నెక్స్ట్ స్పీకర్ పాపం అతను వెయిట్ చేస్తుంటారు. దిస్ ఇస్ చెయ్యేరు రివర్ నియర్ నందలూరు. దిస్ ద రైల్వే బ్రిడ్జ్ అక్రాస్ చెయ్యేరు రివర్ నియర్ నందలూరు. నెక్స్ట్ స్లైడ్ ప్లీజ్. This is again Somasila Reservoir in Nellore. Next. So next, it's an important topic. What is the criteria for recommending rainwater structures? So there should be a weathered peneplain, moderate density of lineament should be there, upstream of groundwater irrigated areas should be there wherever you are proposing a structure. Number of wells in the downstream side should be present, and the slope should be 0 to 5% slope should be there. So what are the things that should avoid is black soil areas, dike rock outcrops, lithological contacts, command areas, salt affected lands, and double cropped areas should be avoided for recommending a rainwater harvesting structure. Next slide, please. So what are the types of rainwater structures? There are different types of rainwater structures. I have listed out only some main rainwater structures like check dam, percolation tank, gable structure, subsurface dike, farm pond, continuous contour trenches, recharge pits, like that. Next slide, please. So what are the check dams? check dams, where do you construct a check dam? Check dams may be constructed on first or second order streams with having a slope of 0 to 5% slope. The cost of the check dam naturally includes 50,000 to 1 lakh for a structure of 10 to 12 meters length. Percolation tanks may be recommended on 1 to 3rd order streams located on plain areas, especially with sufficient weather zone fractures and where the acquisition of the land for large areas is possible. Because percolation tanks, the water occupies for a larger areas, so you have to acquire the land for inundation. So wherever the acquisition of the large areas is possible, those areas percolation tanks may be recommended. So small check dams and percolation tanks with more number of frequent interval preferred over a large single structure because of the smaller gestation period and more fillings. So if you construct a different types of if you construct a number of check dams and percolation tanks at frequent intervals, you have more usefulness than compared to a single large check dam or a very large percolation tank or one tank when compared to other number of tanks. Next slide, please. Gabion structures are low-cost substitute for a cement check dams. They are constructed across small streams to conserve stream flows. It is a small bund across a stream with locally available boulders packed in a mesh of steel wires and anchored to the stream banks. In the course of time, the sediment gets accumulated in the interstices of the boulders with the growth of vegetation, and the bund slowly becomes impermeable and retains the surface runoff. This is the Gabion structure. It's a low-cost structure. Continuous contour trenches are generally 0.3 to 0.5 meters deep, made along the contour lines and small hillocks, having 5 to 15% slope to reduce soil erosion and allow water to infiltrate to the ground. Contour stones and bunds are common in low rainfall areas and are traditionally in situ soil and moisture conservation practices to help in improving moisture regime in the surrounding areas. Flowing water is intercepted before it attains erosive velocity by keeping suitable spacing between the bunds. Spacing between the bunds between the two contours depends upon the slope of the area and also the soil permeability. Next slide, please. So check dams. These check dams meant for different purposes. Check dams may be primarily used for recharge groundwater. Check dams are used for dilution of fluoride concentration. Check dams are used for pisciculture. Check dams are used for cattle pond. Check dams are used as a dhobi ghat. Like that, check dams can be used for different purposes. This check dam is meant for groundwater recharge. Next slide, please. This check dam is constructed for the dilution of fluoride concentration in groundwater. This check dam, you can grow fish in this particular. It can be used as a cattle pond. It can be used as a dhobi ghat. It also can be used to dilution of fluoride concentration, and it also used for recharge groundwater in the downstream wells. Like that, the uses of check dams are multidimensional. Next slide, please. So this is a percolation tank, small percolation tank in a watershed area. This is meant for recharge to recharge groundwater. Next slide, please. This is a farm pond in a watershed. So this farm pond is meant just to have one life-saving irrigation. If people say about if one rainfall is there, ఒక్క తడి ఉంటే సరిపోతుంది, కొంచెం ఒక్కసారి చేస్తే పంట కోసేయచ్చు అని, in those situations this farm pond is very much useful for one life saving irrigation. These are all constructed in different watershed types, is part of the watershed development program. Next slide, please. So wherever there is no drainage, these recharge pits are constructed. Mostly these recharge pits are constructed in our roadsides, in our apartment complexes, and like that, these recharge pits are constructed. These are all very much useful for our groundwater recharge. These recharge pits are constructed wherever there is no drainage network is absent. So these are all also very much present
in all multi-story complexes, in the city areas, in the urban areas, along the roadsides, within the apartment complexes, these recharge pits are constructed. This is a very simple cross section of the recharge pit. It costs around nearly 20 to 30,000 rupees per pit. Thank you very much. Next slide. This is the end of my lecture. Thank you very much for your patient hearing. So, thank you very much. I thank Sunita Madam for giving me the opportunity to deliver a lecture before you all. I'm very much happy to share my views with you. Thank you very much.
So thank you. We appreciate for sparing your precious and valuable time to be with us today as well, in spite of your hectic schedule. We appreciate your support and cooperation in this scientific endeavor. We look forward for your persistent and consistent cooperation in future scientific endeavors too. Being the son of the soil, we are so happy to have you. And your talk on especially Kadapa district that has covered a panoramic view of a variety of topics with pictorial representation, especially the field pics are really catchy, interesting, impressive, inspiring. Appreciate all your support. Thank you for being with us. Thank you so much.
Thank you very much. Thank you very much, Madam.
Good morning, sir.
Thank you, Dr. Jairaj, sir. Professor Jairaj. Anybody would like to interact? Okay.
Any questions are there?
I think
Sir, good morning, sir.
Good morning.
Sir, I am Geosciences, sir. Kiran Kumar.
Chepandi.
Sir, what you have told all cattle ponds also using for cattle drinking purpose and for recharge structure, sir.
అంటే check dam has a multi-dimensional uses and check dams are used not only for recharge groundwater, it can also used for dilution of the fluoride concentration, for improving the pisciculture, for cattle pond, and Dhobi Ghat also can be used. In different purposes, these check dams are used. But the main purpose of the check dam is to recharge groundwater and to dilute the fluoride concentration. These are all subsidiary things.
These are all are using in used in watershed and Dwama, sir. Dwama also
Yes.
doing that.
Yes. These are all watershed development programs. All these things are used in the watershed development program. These are all there. Yes.
Thank you, sir.
Thank you.
okay. I think Dr. Kiran, you are clear, right?
Thank you.
Okay, if there are no questions, I should thank Dr. Raghu sir. Sir, thank you so much for your detailed illustrative lecture with a beautiful presentation and beautiful slides on the entire YSR district. So thanks a lot, sir, for your sparing valuable time in your busy schedule.
Thank you, madam.
Sincere apologies for anything, any lapses.
No,
Please excuse us. Thank you, sir.
nothing. Everything went on well. Thank you.
sir.
Thank
sir.
you. Thank you for giving me this opportunity,
And
madam.
we have number of applause in the chat also. Thank you. Manadu video. Thank you, sir.
Thank you.
Okay. So with this, the fourth technical session is over. Now welcome to the fifth technical session. So we have eminent speaker, Dr. D. Srinivas Sharma Garu, scientist, CSIR NGRI, National Geophysical Research Institute, Hyderabad, Telangana. Now may I request Dr. Srinivas Garu, Associate Professor, Department of Geology, to welcome Dr. Srinivas Sharma Garu.
Yeah, good morning all.
Morning, sir.
Madam, shall I share my screen?
Yeah, you can do that, sir. Before that, may I request Dr. Srinivas Gaud, sir, to read out your biodata.
Yeah, I'm not able to hear anything. Are you able to hear me?
Yes, sir, we are here.
Okay. Yeah. Hello, Gaudgar.
Sir, good morning, sir. Good morning. It's my privilege. It's my privilege to introduce Dr. Srinivas Sharma this national workshop. He received BSc and MSc degrees from Usman University and joined Geochemistry Group NGRA in 1995 in the project to work on the exploration and understanding of the genesis of gold mineralization in the banded iron formations of the Darwar crater. Currently, he is a senior principal scientist and he is the head of the Geochemistry Group. He obtained PhD degree from Usman University on the topic of geochemistry and the genesis of gold mineralization in the bayous of the Gadag resource belt. His main contributions are the age dating of the gold mineralization events in Hatti, Gadag, and Ajanahalli gold deposits by the uranium method on the phosphate minerals in the alteration assemblies. He was the first person to provide age constraints on the gold deposits and study the genetic aspects of gold mineralization in India. He has provided an emplacement age for the plagio-granites of the Andaman Islands, which in turn provided the constraints on subduction magmatism. He has awarded the most prestigious Boys Caste Fellowship and Ramar Research Fellowship by the Government of India. As part of various research projects executed in NGRI, Dr. Sharma worked in different parts of Karnataka and Andhra Pradesh to study the archean crustal growth processes. In association with industrial partners of NGRI, he had also worked on exploration projects in India for the base metals in Rajasthan in collaboration with Hindustan Zinc Limited and abroad for gold exploration work in northeast part of Madagascar in collaboration with NMDC.
He has produced 6 PhD students under his supervision, and currently he is supervising 5 more students at CSR NGRI. He visited several countries including Australia, Canada, Russia, China, Japan, and Madagascar. Dr. Sharma is bestowed with the National Geoscience Award 2019 by the Ministry of Mines, Government of India, under the Basic Geoscience category, and he is an elected fellow of the Telangana Academy of Sciences. So with this brief biodata, I welcome Dr. Srinivas Sharma Garu to deliver his talk.
Okay, at the outset, thank you, Professor Sunita, for inviting me. You are able to see my slides?
Yes, sir. Yes, sir.
And I am audible. I just can go ahead, right?
Yes, sir.
Okay. Yeah, at the outset, thank you very much, Professor Sunita, for inviting me to be part of this national program. And thanks to Dr. Srinivas Gaud for introducing me with some good words. So, as mentioned in the title itself, I am going to talk about, I'm told that most of the audience are research scholars and students. So I thought I will just briefly project what are the opportunities and what are the research possibilities. The possibilities here means the research possibilities for any researcher, maybe a PhD student or non-PhD student, whomsoever, in geochemistry, basically. So as I belong to the geochemistry community, so I'm going to introduce you to some analytical tools, what we are working on and what are installed here at NGRI and what are available for all of you on time to time basis. So our institute, National Geophysical Institute, has completed 60 years in 2021. So we are a kind of mature institute under the umbrella of Council of Scientific and Industrial Research. So slides are moving. Yeah. So initially, in this particular presentation, I'm going to talk about what is CSR and what is CSR NGRI, and then we'll move on to the opportunity possibilities for the youngsters to take up geology as a career or earth sciences as a career, and then research possibilities, what we do here at NGRI, and facilities open up for all of you. So in that we will first see the rocks under the microscopes. That is what is our field of study, and that is the optical microscope. Though I will not deal much about the optical microscope. I will deal with the SEM because I am going to talk about the instruments, and then we will talk about what is the uses of XRF and ICP-MS, how they work, and what is the kind of data that you can get out of these two equipments. And then we will move on to the isotopic analysis and geochronological studies. And finally, I will project a couple of my case studies in the form of case studies to all of you. So we'll move on. Yeah, this is the network of CSIR, Council of Scientific and Industrial Research, which is a government-funded institute, a chain of institutes rather. I would say there are 30-odd labs in the CSIR. Several of you are aware of this fellowship called CSIR JRF, which most of you may be holding or appearing for these fellowships. So CSIR gives that fellowship. CSIR conducts the exam and gives the fellowship. And under this umbrella, broad umbrella of CSIR, there are 39 labs working in different fields of science, starting from biology, chemical sciences, earth sciences. You can see this India map. The labs are spread across the country from north to south, east to west. And we are all, able to use this online mechanism because of the COVID. The online mechanism has become very prevalent. The COVID has actually completely shaken the world, and we were all, victims in some form or the other. So under this COVID pandemic, the CSIR labs, several of the CSIR labs have contributed in their own form. For example, all of you are aware of the Covaxin vaccine that is being, most of us got administered. part of the research, some part of the research, though it is produced by Bharat Biotech, but part of the research was carried out at IACT, Indian Institute of Chemical Technology, which is next door. So there are 3 labs in this road called Tarnaka Uppal Road. CCMB, which takes up biological work, the DNA sequestration, whatever is being done, is the outcome of the technology that is produced here at CCMB. So these are the 3 labs that are here at NGRI in Hyderabad. So there are several other labs, as maybe you can see on the internet Google platform what are the contributions of each individual lab. So at NGRI, National Geophysical Research Institute, the name itself says that it is a big geophysical research institute with a lot of geophysical instrumentation and a lot of geophysical surveys that are being carried out. So we work on the exploration of hydrocarbons, minerals, and groundwater resources. In addition to these studies of engineering geophysics, seismology, most of the earthquake studies are being done here. And finally, we also carry out work on the geodynamics, both through geophysics as well as geochemistry, geochronology, geochemical, geodynamic studies. And then we also work on, some of my colleagues work on the geoenvironment, that is the contaminant studies and remediation studies and all that. And we have a strength of 120 odd scientists now, and there are around 200 odd research scholars working in NGRI. So this is how the main gate of CSR NGRI will look like, and we have a big bunch of books and collection of research articles and subscription to different research articles in the form of a library, big library at NGRI. And this is our, iconic green building. And these are the different research groups working at NGRI. Some group working on earth processes modeling, electrical geophysics, electromagnetic studies. You can see geochemistry, geochronology, a big lab of geochemistry, geochronology with a lot of instrumentation facilities. And there is a section called instrumentation, seismics, and seismology. So each section got its own mandate of activity carrying out in different fields of science. So people work on groundwater management, assessment, and groundwater resources modeling studies are being done. Several people work on different different geophysical tools to do the refraction studies and deep resistivity studies, in groundwater and magnitude tellurics, and different kinds of geophysical surveys are being done. So some group also works on the GPS measurements to understand the relative motion of these plates and understanding the Antarctic plate as well. And there is a station in Antarctica. So now in a big way, our people are working on airborne geophysical surveys for magnetic, radiometric, and electromagnetic data that is being obtained through airborne, which is less time consuming to survey a larger area. So all this data, whatever geophysical data which is collected, there are big computers to interpret and model to the geophysical data that is obtained. And then, as I was mentioning earlier, the environmental studies are also being carried out. So towards the opportunities, if we talk about, several of you are aware, but those who are not aware, maybe you can make a note. There is a lot of recruitments going on nowadays in both state government as well as central governments. Most of the central government recruitments are in the form of geologists or assistant geologists through UPSC, and several people also appear for GATE exam, which is a nowadays mandatory requirement for ONGC. Central ONGC GATE score is very much required. So all these are the government organizations which take the GSI, Geological Survey of India, takes a lot of geologists, geology students through UPSC only again. So there will be some requirement in the form of AMD to at BARC, Indian Bureau of Mines, state boards, state geophysics board, and geology, mines and geology departments. So there are lots of other public sector undertakings which take a lot of geology students. like ONGC, NMDC, MMTC, NTPC, all these organizations absorb several of geology students. And then there are lots of private sector jobs also abroad. When there was a big mining boom, several people were absorbed in different private companies. So some private companies are operating here in India as well, but most of the absorptions are in the Canada and Australia. So you can try these companies as well, like Broken Hill, Rio Tinto, Kane Energy, Reliance Energy. So all these are the opportunities. But if somebody is interested in not in job and only somebody wants to do research, carry out research and complete their PhD and postdoc, so there are lots of opportunities with the fellowship called CSIR UGC fellowship. For that, you have to write a national eligibility test, NET exam, and there is a DST Inspire fellowship also, which will be available for the topper of the class. So hope you are all aware. But just to brush upon. So there are lots of other international fellowships also, provided by different organizations. There is a fellowship called SCAR Fellowship. Those who want to, particularly work on Antarctic research, and Humboldt, a German organization, will also provide the fellowships, and several DAD fellowship, SERB also provide some fellowships for women. There are lots of other opportunities in the form of women scientist scheme and women scientists. Even doctoral fellowships are also available. So one can try all these possibilities, but there are several scores of opportunities, and several of the positions in the state universities and central universities are vacant. So hopefully the governments will take steps towards filling up those positions with the most of the research scholars. But before that, you also have to have your fellowship, CSIR or UGC qualified fellowships. So you should try for that. So several of IITs and ICERs nowadays have geology or a broad umbrella of earth sciences departments at several ICERs and IITs and NITs. So you can look for these jobs as well, and work for PhDs in all these institutes. So in CSIR, we have two labs, NGRI, our lab, and NAO, National Institute of Oceanography in Goa, which takes lots of geology students. And there are other central government institutes like Wadia Institute of Himalayan Geology, Indian Institute of Geomagnetism, NSES in Trivandrum, INCOIS. So like that, there are several places one can try. And there will be lots of project assistants, advertisements from time to time in different organizations. So you can try for at least these project assistants positions, which actually gives you some entry to these research institutes, where you can spend some time and then get used to and write for the other exams and appear for all other courses. So these are some of the research institutes within CSIR where there is a lot of geology input, though they are not directly related to geology, but CBRI, Central Building Research Institutes in Roorkee, which does a lot of earthquake related studies. There will be a lot of though it is engineering based lab, but there will be some geophysics people who can work. SCRC is another lab, and this is another CSR lab where people can try. So now these are the opportunities that I talked about, but now we'll move on to the research part of it. We'll first understand after getting the sample from your field work. So what we do actually, I am trying to propose before you. But you also can follow this procedure or some other procedure depending on your need and necessity. But I am trying to open up all the possibilities, research possibilities, with geochemistry and geochronology. So this petrography, one has to do the petrography with a thin section to start with for identification of minerals and composition of those minerals. If you have some tool to understand the chemical composition, then one has to understand the textural relationships before you really go for any geochemical data analysis. Then finally you have to classify those rocks before you really get into any of the geochemistry tool. So if you don't understand your petrological information, if you don't have thorough petrological information, all the geochemical data, whatever you are going to get, you may not be able to interpret it properly. So this is a normal microscope which may be there in several of the universities. All of you must have gone through this one during your MSc studies. But I am going to introduce you to from optical microscope to the scanning electron microscope, which is slightly higher energy microscope, high end microscope. I would say I would call it as a advanced petrographic tool. The regular petrography that you can do with the light microscope. Now we are migrating to electron microscopes, which is called a scanning electron microscope. I'll just briefly introduce what are the capabilities of this particular equipment and how it will be useful for the research studies. Okay, so with human eye, you can see only some objects. With several of us, even I am using a some tool like the specs to see some of these things. So with optical microscope, you can see things up to 100 times magnified or 110 times magnified. But with a high resolution SEM, scanning electron microscope, you can see of the order of nanometer scale. So you can see the minerals or the relationships, interrelationships of these minerals, at a very high resolution, at very high magnification through a scanning electron microscope. That is what I am going to show you as we go on. So whenever there is a electron beam touching the sample, the electron beam is used as a tool. In optical microscope, people use a light as energy source, but here we are using it as a electron source for the looking at a sample. So when the primary electron beam falls onto the sample, the whatever material, maybe it is a geological material or any other material, they emit different types of electrons. They are most useful electrons are secondary electrons, which we will be talking about in future slides, in next few slides. Secondary electrons and backscattered electrons. So these are the two types of electrons that are required for us to make a image. And we also require this cathodoluminescence electrons at some stage. This is a specific property for some minerals, some materials. Only if you have a CL response, then only these electrons will be emitted and they will be useful. So we'll see how they are useful. So these are secondary electrons that will give a image of mainly topographic information. The superficial information on a sample, whatever sample you are looking at, will be seen with the secondary electrons, which may not be very useful for our geological purpose because we will be making a thin section and polishing the surface. So this may not be very useful for us, but this has got applications in several other fields like paleontology, maybe in material science like that. But we most prolifically used electrons for us in the geological study or geochemical study, the backscattered electrons. They work based on the mean atomic number of that particular mineral or compound or the element that we are looking at. So this gives a bulk signal dependent on the mean atomic number. I will show you some examples, maybe you can appreciate at that time. So the cathodoluminescence is mainly used for zircon. Zircon, hope you are all aware that zircon is the most prolific geochronometer now being used for the age dating of different rock types. And we also have a detector called the energy dispersive spectrometer, which gives the qualitative chemical composition. We will see how it will be useful. And yeah, as I was mentioning, these are the basic information that you can gather: topographic information, compositional information, morphological information, and some. If you do advanced petrography at very high resolution, you also can obtain the crystallographic information. So this is the comparative diagram illustrating the differences between the optical microscope, which uses a lamp as a source, and electron source is used in the scanning electron microscope. So the sample will, the electron source will touch the sample, and then it emits different types of electrons, and finally it goes to a CRT tube, and that creates an image. So we will see how those images will look like. So if you see the energy levels, 2-3 points here, you remember the optical microscope, in terms of high electron volts, it is 0. So we are using light as a source, so which is very low energy. But in a scanning electron microscope, we will be using the electrons as source. So within the electrons also we can use at different levels depending on the sample that we are working on. So we can use from 0.5 kV to 30 kV, but generally for our geological purpose we use 15 kV as a possible energy, which is sufficient enough to get all the information that we will be looking at. So if you see the resolution in optical microscopy, your image will stop at 0.1 micrometers, but whereas in scanning electron microscope you can see things of the order of nanometer scale. If you see in terms of magnification, you can see maximum in an optical microscope of 1000 times. That is 1K. The magnification of 1000 times magnified. But here, if you see in a scanning electron microscope, you can see things up to 80,000 times magnified. Theoretically, up to 1 lakh times magnified, which is really very, very high to understand the advanced petrographic information. So this is how the cross section of a scanning electron microscope will look like. There will be electron gun which will be emitting these electrons, and then there will be different condenser lenses to narrow down the beam. And this is the technique which is followed almost all of the analytical tools. They all work under a considerable amount of vacuum, and these secondary electrons which are emitted from this particular sample, whatever sample you are working on, they will go to amplifier and finally go to a CRT tube, and through a camera we will get image displayed on our screen. So you can see here, this is the equipment, scanning electron microscope equipment, which is installed here at Geochemistry Division of CSR NGRI. So there will be a sample in this particular sample chamber, and these are the different detectors that are useful for our purpose. So these are the two screens where you can see the image, and we also can obtain the energy dispersive spectrometer, which will give the qualitative chemical composition. So we will not really go much deep into the vacuum things and physics part of it. So there will be some vacuum which is maintained in the chamber, which will really will be useful to narrow down the electron beam and not deviating from the our source, that is the sample. Finally, the electrons have to touch the sample, and then we should get the image. So there will be some sample preparation, little sample preparation required for working on a SEM. Definitely our thin section, whatever thin section you are making for petrographic studies on the optical microscope can be used. And some samples needs coating, but if you are working on a low vacuum mode, then you really don't have to coat the sample with your thin section. So coatings also are different types. Gold coating also possible, and carbon coating is also possible. So these are some of the images that I am trying to show you. Whenever you see a scanning electron microscope image, you should see these. There is a scale which gives the the size of the image. So this scale is 1 micrometer scale. So that means which is very, very small object. So this is magnified 30,000 times. If you see here, with the into symbol x 30K. So this image is taken at 30,000 times magnified. This is a secondary electron image which is giving the morphological information. And the second one is a backscattered electron image, which is also obtained at very high magnification of 50 times magnified. And you also can see the how much kV HV is being used in the form of electron volts. And these two bottom two are the cathode luminescence images, which are will be very useful to identify the core rim relationships. The center one is a core which may be older sometimes, and the rims the rims are maybe of different age. So you can see this zoning. This zircon has got the property of giving the cathodoluminescence. So those cathodoluminescence images will be useful for, while doing the geochronological studies. So we also have a small attachment called energy dispersive spectrometer, which actually gives the qualitative chemical composition. So when the lower orbital electron, this electron, whatever we are pumping in, emits the lower orbital, ejects the lower orbital electron, and the second image you can see the atom tries to the excited atom tries to get back to stability while emitting an electron from the outer orbital to inner orbital. So when this electron is coming from outer orbital to inner orbital, it emits a characteristic X-ray called photon. These photons are characteristic for each of the elements. So this energy will be going to the detector, and then finally it gives a kind of peaks like this. So you can identify based on these peaks. Say for example, here iron peak is the highest, and there is chromium present in this particular sample or the place where you have analyzed. So this kind of histograms we will be getting as an output with the EDS detector, and based on this we can identify which mineral we are targeting or which material we are trying to analyze. So this will be very useful to understand some of these materials like shown here. You see a monazite associated with a arsenopyrite in a gold mineralized zone. You can see the brightness contrast variations, the monazite, because it has got rare earth elements in its composition. It is a rare earth element, light rare earth element phosphate, which is much brighter than the arsenopyrite. So we can identify like this, and if you just analyze this particular place, it will give you a peak of rare earth element, lanthanum, cerium with phosphorus, and that is it can be identified as a monazite. If you see here on the right side, there is another ore forming mineral assemblage. If you see gold associated with arsenopyrite and pyrite, so you can very easily identify on these grayscale variations also. This is a compositional image, BSE image, backscattered electron image. The mean atomic number of gold is really high, so it is brightest. Arsenopyrite is next higher, and pyrite is the next one, and the surrounding mineral is a quartz. So the most of the gold mineralization occurs in quartz veins. So the surrounding mineral is quartz, so that is darker. So on the basis of these grayscale variations, and maybe using one small EDS spectra, we can identify what mineral or what are the interrelationships of these minerals. Those things can be very easily identified with a advanced petrography called scanning electron microscope petrography. Okay, then the bottom one is a pollen grain. Some of the biology people, they want to understand the internal structure of the pollen grain. Then so you can see these small spikes present here. This is also a scanning electron microscope image. So it has got lots of applications. Yesterday, Satyanarayana Reddy sir was mentioning about the exploration. So all these geochemical tools, whatever I am going to talk about today, will be useful in the exploration part. But it has to be judiciously used. Which equipment will be useful for your kind of exploration that you want to do, you want to carry out. So after the SEM, scanning electron microscopy, so the petrography is done now. So now we have identified what rock type we are looking at or what rock type we are studying. Then we are slowly moving on to understand the composition of that particular rock. So the 99% of the composition, whatever we are trying to look at, we will get with the instrument called X-ray fluorescence spectrometer. The X-ray fluorescence spectrometer is very useful, and there are different types. Whenever we are talking about the ED, earlier instrument I have introduced, energy dispersive spectrometer. Whenever we are talking about ED, it gives qualitative chemical composition. But when we are talking about WD, the wavelength dispersive spectrometer, that is why specifically it is written as WD-XRF, which gives quantitative information. So that quantifies the elements present and also gives in terms of percentages or ppm. So that is done by using several standards. So XRF is one particular equipment which gives the 99% of the composition of the of the rock or material, whatever you are trying to, use. So we use X-ray. So I don't really have to introduce to you people how the X-rays are being done. They were discovered accidentally by this man called Rodgen, when he exposed his wife's hand under these things, and he by this he has identified the X-rays, and the X-rays have lot of applications. Whenever our bones are broken, whenever there is a fracture, so all those times we use X-rays. So same X-rays we are going to use here to get the chemical composition. So these are some of the physical properties of these rays. So you all know visual. At some stage we can see if then there are UV rays, then X-rays, gamma rays, all those things as the energy increases. So all those things are taught in very preliminary stages of your schooling. So I'm skipping those things. So the applications of radiology, CT scan, radiographs, they are all being useful in for our joints, when the bone is broken, those things. But X-ray fluorescence, we are using it for elemental composition. Okay, so how it works, we will see. When a sample is subjected to these X-rays, so when primary X-rays fall onto the sample, then they emit these secondary X-rays. That is what I was mentioning in the earlier instrument when I was talking about the outer orbital electron falls to the lower orbital to attain stability, and it emits a characteristic photon, and those photons are characteristic for individual elements, and those energies are caught here, and they are standardized based on using different matrix match standards, and the energies also are different because there are different shells, K, L, M, and shells. So these energies are also different for each of those shells. So where from this electron is coming, and those energies are different, and those energies are reaching those intensities are reaching our detectors, and finally we use them to get the final information of the concentration, which is our need. So this XRF, WD XRF is a kind of non-destructive thing, which actually uses wavelength, is directly related to atomic number of that particular element, and this intensity is based on the concentration of that particular element. Those intensities will reach the detector, and finally they will be converted into concentrations. So the X-rays are useful to to measure all these elements. You can see all these elements. I don't have to read out all these elements, silicon, aluminum, but they are all measured in the form of oxides, SiO2, Al2O3, like that in the rocks. And some of these elements like arsenic, barium, cadmium are also can be measured, because the oxides are measured in terms of percentages, because they are having lots of higher abundances. But these elements, the trace elements, are in ppm level, so they are measured in ppms. So we can measure these elements in rocks, soils, and also sediments, and of the order of even few ppm can also be measured. So these are two equipments which I am talking about, the EDXRF and WDXRF. Whenever we are talking about ED, it is only a qualitative information that you can obtain. But WD, when we are talking about the wavelength dispersive spectrometer, we can get the quantitative chemistry of that particular material, whatever we are trying to subject to. And the EDXRF, like I was mentioning earlier in the histogram, it gives only the elemental peaks. But in WDXRF, it is given in one particular peak, and finally the concentration. And then we have at NGRI in our section 2, 3. Now we are using a third generation XRF, which is pan-analytical equipment. We had earlier two other earlier equipments which are being discarded right now, and we are using this third generation XRF now, which has also got auto sampling facility. So sample preparation is very simple for any XRF. I just minimize this. Okay. So often very small sample material is required. So of the order of few grams, maybe 1 gram or 2 gram sample is sufficient for analysis. Whatever sample we are trying to measure should be a representative sample. So it should represent all the rock that you are trying to analyze. So the coarse grained rock, you have to be very careful while analyzing coarse grained rocks, because different minerals are at different places. So you have to have a uniform composition or homogeneous material. So this finally the sample will go into a cup. I will show you how those cups will look like. So there are two different sample preparation techniques, which is a fusion technique, which is not very much used, because we have to heat the temperature of the order of 110 degrees centigrade, 1000 degrees centigrade temperature, and everything will get fused. But the pressed pellet are generally being used by using boric acid. So this is how the cups will look like, the XRF cups. So boric acid will be filled in the initial stages, and on finally a sample will be sprinkled on it, and that will be pressed in a pressed pellet. So you can see this is the fusion pellet, and this is a pressed pellet system that is being used for final analysis. So there are some procedures to finally calibrate what material you are trying to use. So one has to have these standards, matrix matching standards to of the different concentrations. So whatever material you are trying to look at, say for example a granite. So granite will vary with silica composition. So whenever you are trying to have, you have to have a peak of appropriate standards, and so finally these calibration lines will be made, and finally your samples unknown will be analyzed. So there are lots of applications, as I was mentioning earlier. So it has got applications in mineral exploration, whatever you are trying to analyze. So there is a big program of geochemical baseline mapping that is being done by Geological Survey of India nowadays. So they are mapping the entire country with several samples. So they are analyzing something like 25 elements by using the XRF, 25 elements by XRF. So all those maps maybe eventually will be useful. So we also can measure the pollution contents, either natural or anthropogenic pollutants, that can be analyzed by using a XRF, and some other screening of these metals also is possible by using a X-ray fluorescence spectrometer. So finally, when we get this, okay. So when finally we get for a rock, because we work mostly on the rocks. So finally, when we get the major element composition, if we just plot on these two very basic plots, silica versus SiO2 versus alkalis, that is sodium and potassium, Na2O and K2O, we'll get a plot. This is the most used diagram in any of the geochemical classification. We will be able to identify what we are looking at. In this case, they are basalt to basaltic andesitic in composition. So this kind of information we can get just by major element analysis. And then we also will be able to discriminate even to some order even the tectonic setting, that is whether they are tholeiitic basalts or calc-alkaline basalts, like that. Some very basic information will be very useful in deciphering some of these tectonic setting, or classifying those rocks. Those rocks anyway you have known by petrographic study, but this is a second level confirmation of your results based on the petrography. So now we understand the 99% of composition of the rock, whatever we are trying to work, or soil or whatever it is. But the 1% left out 1% of the material which we want to understand in the rock or mineral, whatever. So there is another next level equipment called the ICP-MS, inductively coupled plasma mass spectrometry. So what we have here at NGRI is a high resolution ICP-MS. I will introduce through these ICP studies. So the applications of ICP-MS again, it will be useful for characterization of the rocks and soils. The geochemical evolution studies are being done. The crustal evolution studies that our group does, in different cratons and mobile belts. People use these geochemical data, the 1% of data, that is the trace and rare earth element data produced by this ICP-MS is being used. So people also use it for understanding the tectonic setting. And as I was mentioning, as Reddy Sahab was also mentioning yesterday, the mineral exploration studies, it will be very useful. So you can analyze most of the elements. You can name an element, you can analyze gold, silver, platinum. So all those elements can be analyzed very precisely by using this the ICP-MS. So some of these toxic elements also can be analyzed, which is very useful in environmental assessments and contaminant transport. So just to introduce to you the ICP-MS, the inductively coupled plasma mass spectrometry. So this is the procedure that we follow in our laboratory for rocks, basically rocks or soils mostly. So any sample which is taken, a homogeneous sample, very small quantity of the order of 50 microgram sample is being used. Again, it has to be homogeneous and it has to be very finely powdered. So the sample will be on hot plate for at 150 degrees centigrade for 48 hours. 48 hours on hot plate. So which will be something like 8 hours per day if you take something like 1 week. So 5 working days or 6 working days time we contribute, which will actually dissolve all the material in acids, the kind of acids that we use, hydrofluoric acid, HCl, and nitric acid. So this will be digested. So these are some of our lab benches which are being used for this, some of these units which are being used for digestion of the sample. And some of those difficult to dissolve material, some material like chromite or zircon, which is difficult to dissolve. So it doesn't really easily get dissolved in the
Excuse me, sir.
Yeah.
Sir, sorry to interrupt you. There was some disturbance, some box like this thing is coming in the PPT, sir. Can you have a look on that?
I am only drawing it, madam.
No. There is some box like square like this thing is coming on the slides, sir.
So you want me to stop share and these lines I am drawing?
No, not that one. We could see some square shaped box is coming in between the slides.
Collapse window, yeah. Now?
Little bit reduced. Still.
Yeah, that is the window that was coming from the beginning.
Okay.
I was trying to adjust myself.
It's okay. And now it's clear. Okay.
Now I think it is a very small one.
Okay. Yeah. Thank you, sir.
Okay. Yeah. Okay. Sorry for the disturbance. Yeah, these are the some of the difficult to dissolve materials like chromite and zircon. So they are being digested with a high pressure asher, which actually dissolves all this material. So if it is not completely dissolved, we will not be obtaining the values that we are aiming at. So these are the other equipment. There are different types of ICPs in the market. So there is a ICP called quadrupole ICP-MS, which is the first invention, which was very in the very beginning in 70s and 80s people have used. Now also it is being used for different purposes, which is the throughput is very high, so people use it. And what we have here at our division is a high resolution ICP-MS, which actually the sensitivity is very high. So I will explain to you what I mean by sensitivity, and which is very useful for some of these analytes. And there are other most vibrant things are multi-collector ICP-MS. In both in quadrupole and high resolution ICP-MS, we have only one detector which detects all the elements. But in multi-collector ICP-MS, there are 6-7 Faraday cups at the end of the equipment to detect all these material. So the isotopes, this will be more useful for precise isotopic measurements. That is called multi-collector ICP-MS. So we will not worry about the other, ICP-MS, which are not very useful in our geochemical analysis. So again, the history of these ICPs at NGRI as it goes. So the first ICP-MS was installed here at NGRI in 1987. This was the first first such kind of equipment in the country. And now we are with this third generation HR ICP-MS, which is installed in 2013 and which is also almost 10 years old, but which is functioning very well. We also have a laser ablation system attached to this particular equipment. I will explain to you what is the use of this laser ablation as well. So we'll not get deep into it because I myself don't have much expertise on this. So the liquid sample, finally, whatever digested sample in the in the lab, wet chemistry lab, will go to this lab for the analysis of different materials. And this is the cross section of the HRICP-MS. The sample will be introduced from the source, and then it goes through these ion beams and also goes through the magnet, and finally it goes to a detector where the intensities of this material will be taken, and finally that will be converted to the concentrations. So it detects multi elements, so different number of elements in one particular go. So this will be very useful. As I was mentioning here, we have only single detector. In multi-collector ICP-MS, there are several detectors that you can see here, which will be very useful for isotopic measurements. So these are the two equipments. Both are installed here at NGRI. One is called multi-collector ICP-MS, another is HR ICP-MS. And these are all the possibilities of analysis of different elements. I'll just skip this and go to the next one. So you can see, almost all the periodic table can be analyzed, but you have to have different, sample digestion procedure for different materials what you are trying to analyze. So we can analyze of the order of ppb, parts per billion, parts per trillion, and parts per quadrillion also is possible by this inductively coupled plasma mass spectrometry. But what we are looking at here at NGRI for our own studies is this particular elements called rare earth elements. Rare earth elements starting from lanthanum to lutetium. So these are the 10 elements which will be very useful for deciphering the tectonic source. So these elements are being analyzed basically along with some of the other trace elements like scandium, vanadium, and things like that, which will be useful for some of the geochemical discrimination diagrams. So the mention I made in the beginning, like the high resolution ICP-MS will be, the difference between these two is with a quadrupole ICP-MS, we use argon as a carrier gas. So whatever material we are trying to analyze is carried along with argon gas. So these Fe56 and argon oxide have same mass, which may not be able to distinguish, which we may not be able to distinguish by quadrupole ICP-MS, but with a high resolution ICP-MS, even with this subtle difference at third decimal stage, 55.935 and 957 also can be measured. The peaks are being separated here. You can see very clearly with the high resolution ICP-MS. So that is the usefulness of this particular HR ICP-MS. So these are all the elements that can be measured with these mass numbers: scandium 45, vanadium 51, like that. So all these are the most abundant isotopes. So those isotopes can be measured by HR ICP-MS. So these are some more detailed information which will be useful for trace element measurements with the ICP-MS. So when again earlier I have shown you the usefulness of in terms of some plots how the data will be useful. So here I am trying to impress you with the some of these elements that are being measured by ICP-MS like samarium by neodymium and cerium by lead. So these two ratios, if you calculate and finally measure, you can identify where your samples are falling. So all these patterns, whatever I have drawn, like OAB, MORB, all these things are drawn by compiling several data sets by several authors generated at different labs, and all these geochemical discrimination plots are being made by different people. So these plots are standard plots which are being used across the at different places. So they will be useful discriminating some of these information. So these are called some tectonic discrimination diagrams, which will be very very much used in the geochemical studies. So these are the most most of the people use these rare earth element patterns and the which is normalized by chondrite, rock by chondrite and rock by primitive mantle normalized diagrams. They have their own usages. The small kinks of negative europium in some rocks will some sediments, if you for example talk about the is inferred for the reducing environments at the time of formation of those rocks. For example, these niobium tantalum anomalies, negative anomalies, will indicate the crustal contamination while these rocks are coming up to the crustal level. So all those interpretations can be made by using these trace and rare earth element data by which is analyzed by your ICP-MS. So there is a system called laser ablation system, which is used nowadays to understand the isotopic information. So this system is attached. This is an attachment to the regular ICP-MS, which has got lot of applications for us. For geologists, if you see, we can analyze some of the minerals. This actually enables us, to avoid the wet chemistry procedures. So we don't have to spend time for digesting the samples. So we can directly ablate some of the material by using these lasers, and that will finally go to the mass spectrometry and gives us the information. So several minerals can be analyzed, and diamonds, a lot of applications in petrology by laser ablation. So I will show you some examples and how it will work. So trace elements in minerals is possible by some of the mineral. If you have a bigger grain of the order of 100 microns or 50-60 microns, so you can ablate the material from that mineral and you can analyze for the trace element composition. And people very often use these zircons to obtain uranium, lead, and lutetium, hafnium isotopic systematics ages of these different rocks. So all these other minerals like phosphates, monazite, elenite, titanite, all these are also can be analyzed by ablating material from these minerals, and obtaining whatever information you are looking for can be obtained. So yeah. Anyone is trying to interrupt?
Sir, you can carry on, sir.
Okay. I'll finish it in another 10-15 minutes. Okay. Okay. So there are different types of lasers which are being used. The one we have here is this 213 YAG laser, and there is another 193 laser also, examer laser also being installed here at NGRI. So this is how a laser ablation system will look like, and this is HRIC-PMS is a mature technique which is accepted by the international scientific community to analyze and understand the different materials. So now we have done most of the geochemistry part. And these are the most useful or most used geochemistry tools, the SEM, XRF, and ICP-MS. Now we slowly move on to age dating of some of the rocks and some of the minerals, how they are being done. I'll just introduce you to what is geochronology. Geochronology is chronology means time. So geo means understanding the time of the earth material, rocks or minerals. So this is the basic principle for any geochronological measurements is understanding the half-life. Half-life is defined here like whatever is, say, for X amount of material, when it decays to half of it, X by 2. So that is called one half-life, and it can be of several orders. So the second time, if it is decaying, it is second half-life, like that. So the initial material is called as parent isotope, and the final product, say for example, uranium is decaying to lead. Uranium is the parent isotope, and lead is the daughter isotope, like that. So what are the materials which are amenable for these measurements? Geochronological measurements are that depends on the material that you are trying to use, and also the age that you are trying to obtain. Say for example, the younger material, most of the archaeological purposes people use carbon isotopes, because the half-life of carbon isotope is very small. Carbon 14 is in 5,000 years or 6,000 years, I would say. But when you go to, for example, uranium 235 and uranium 238, so they have a bigger half-life, 4.47 billions of years. So that is how people use zircon as one of the material for this. This is one reason which is useful for zircon as is a more prolific geochronometer. And there is another reason for zircon to be more prolifically used is because of its high resetting temperature. So even at 700 degrees centigrade or 800 degrees centigrade, 750 degrees centigrade temperature, if there is a metamorphism which is occurring or some activity going on in the on the earth, the zircon will not get affected. So its composition will not get affected. Whereas if you see some of these potash feldspar and all, which was very earlier used on the potassium argon dating, it gets reset even at 200 degrees centigrade temperature. So like that, people use zircon as most prolific geochronometer nowadays. Monazite also has got reasonably high, resetting temperature. So these are the two, basic things that I have used for my own purpose. I will explain you those two, examples in the case study. So these are the most used equipments. TIMS called thermal ionization mass spectrometer, which is used for some mineral geochronology and some whole rock geochronology as well. The most prolific used instrument is laser ablation ICP-MS. So it has got quadrupole, it has got multi-collector, so which will be useful for zircon analysis, rhenium osmium analysis of sulfides, like that. And the third equipment, which is a very expensive equipment, which is very big equipment, is SHRIMP, sensitive high resolution ion microprobe, which also is being used for zircon analysis and phosphate analysis. So each equipment has got its own limitations, its own drawbacks. So what material you are trying to analyze, you have to choose the equipment and go for that particular equipment. So these are some of the photographs for laser ablation coupled with the ICP-MS, some foreign lab. So this is a SHRIMP, sensitive high resolution ion microprobe, which is you can see it a very big equipment with lot of coils, magnets, and things like that associated with it. This is the thermal ionization mass spectrometer, which is available at NGRI, which I am using for my own work. So I'll close it, close my talk with some case studies. The first case study I am trying to present is the dating of some of the gold mineralization events in Dharwar Ketan. So the minerals that I have used for this particular study is one is zircon, which is a zirconium silicate mineral to determine the age of the host rock. And these two minerals I have used called monazite and xenotime, which are light rare earth element phosphate and heavy rare earth element phosphate, which is present in the alteration assemblages of these gold mineralized zones, which is useful as a hydrothermal phosphate, which is very useful for dating. So to introduce you to some of the gold deposits, so these are the gold deposits plotted in with a yellow mark. So Hatti, which we have used, which I have worked on in the very initial stages, almost a decade or decade and a half ago. So there are lots of other gold deposits in the state of Andhra Pradesh, Ramagiri, Kolar, Kolar, of course, northern part of Kolar is in Andhra Pradesh, and Kolar, actual proper Kolar is in Karnataka, which is the entire area is called as the Dharwar Craton. So I'm just trying to explain to you the Hatti gold mine. This is the Hatti greenstone belt. The Hatti is in the northwestern fringe of the greenstone belt. So there are 2-3 other deposits. One is Ooty and Hirabudini deposits in the Hatti gold mines. This is the cross section, geological cross section of the Hatti gold mine. So these are our sample locations where we have collected a felsic volcanic to work on the host rock, which is a host rock in the Hatti gold deposits. The entire green area is a metabasalt, and we have collected samples from different reefs. So those are being dated. So there is a criteria to identify, monazite can form in different horizons, different, geological regions. There could be a magmatic, it can form in magmatic process, or it can form in hydrothermal process, or it can be metamorphic also. So first one has to identify this monazite that we are trying to, monazite or xenotime we are trying to date is hydrothermal or not. So there is a criteria to follow to identify it as a hydrothermal monazite. So generally the monazites are grow in hydrothermal monazites grow in crusters, that is in the form of flowery structure, and they occur as euhedral anhedral grains. And I'll show you some examples. So see, for example, here this monazite is a very small grain of monazite. This scale is only 10 micron. So they are, grown in flowery structure and distributed all around in the alteration assemblages. So this monazite got, dissociated to form apatite alunite coronas. So that is the indication of the subsequent tectonic activity that the gold deposit has, seen. So this is the photograph that I have shown you earlier. The monazite, the hydrothermal monazite is associated with the ore minerals, and in turn associated with the gold. These ore minerals are associated with gold. So these are some of the zircon mount that I have prepared to date the host rock. So these are the ages that are obtained by using the sensitive high resolution ion microprobe SHIM, and these ages are published. This is the age of the host rock, 2587, and 2545 is the age of the intrusive granite. So this is also similar to the age of the gold deposit. So the gold mineralization. So the granitic intrusion and gold mineralization has taken place at the same time. So it can be named as intrusive related kind of hydrothermal. This is the summary for Hatti gold deposit. So this is one case study I wanted to project. So these results are published in very good journal called Economic Geology. And we also worked on some of the similar studies we have carried out for the some of the western Dharwar Craton gold deposits, that is Gadag and Ajanahalli gold deposits. So these results are also published in another economic geology journal called Mineralium Deposita. And the second case study in geochronology I wanted to present to you today is the age determination of the bedelliite, which is formed in the mafic rocks basically. So whatever zircons are mostly zircons are found in the felsic rocks. Mostly the bedelliites are found in the mafic rocks. So these mafic rocks, the bedelliite grains we separate from the mafic dikes or gabbros. From the, this is from a study from the close to Kadapa basin. So the zircon, the bedelliite grains are, put on a filament, and we make a bead with silica gel, and they are heated to up to the order of 1500 degrees centigrade temperature with the thermal ionization mass spectrometry. So that procedure we have developed here at NGRI, that chemical geology paper you could have seen. So they form kind of flowery structures. This is a study of its own. So finally we obtain the weighted mean ages for the some of the standard and some of the unknown sample as well for the a dike from the Dharwar Craton. And these are some of the other studies that we have carried out. Some study on the datatable zircons from the Dharwar Craton, from the Gadag Greenstone Belt to understand the crustal growth processes in the Dharwar Craton. And these are some of the studies on the tectonic setting of the Andaman ophiolites by dating some of the zircons from a plesiogranite. And yeah, that's it. I wanted to talk to you today. Thank you very much. Yeah, I am open for any clarifications if somebody wants to.
Thank you so much for your beautiful illustrative talk. Now it's a time to interactive session. We will see any questions are there. Any questions are there? How can we see the questions? Yeah, 1 second. Sir, in the chat box, we could see AM Gauri, she was asking, thank you, sir, for giving more information about ICP-MS and all those things. How can we use the laser ablation method for both the dry and wet samples?
Okay. I'm not sure about the wet samples. It may not be possible to use for the wet samples. But for dry samples, it is again the same thin section that we are, making for petrological studies can be used for the analysis of trace elements in the mineral or whatever material you are trying to analyze. Yeah, thin section is sufficient, or you have to make a separate polished section in the form of a mount, epoxy mount, to work on your samples. Mineral chronology or whatever material you are trying to analyze. Solid samples, it is possible, but before that, before people go for the laser ablation studies, they do a lot of imaging, SEM imaging, to understand the intricacies. If there is any zoning, whether chemical or optical zoning is there in your sample or in your mineral, that first one has to understand. For example, the zircon, the cathode luminescence images will tell us the core rim relationships. The core may be older, maybe having very old age. Rims may be magmatic rims which may have very young age. So those things can very easily be distinguished by doing a lot of imaging.
I think it's clear now. DK or something. Somebody would like to ask?
Good afternoon, sir.
Yeah, good afternoon.
I'm studying MSc Geology in Yoga University.
Okay.
Good information, sir. I have a small doubt, sir.
It is not clear.
Elements in
Your voice is not clear. Somehow.
Actually,
how do you measure rare earth elements in ICP, sir?
Yeah, rare earth elements is a very easy thing. We can analyze in rocks or soils by digesting the sample. So one has to digest the sample and bring everything into solution, and that solution will be aspirated into the ICP, and that will be analyzed. By again, we have to have lots of standards, matrix matching standards to analyze.
Thank you, sir.
okay. I think it's clear. Thank you, sir, for your detailed. Thank you for your illustrative talk on covering geosciences, application of geosciences to the students, especially. So the talk was went on very well, and you have shown the chemical analytical methods, XRF, and all the TIMS and other advanced methods. So thank you so much for once again for your valuable time in sharing with us. So if you have no problem, can we share your PPTs to the participants?
You can convert it into a PDF. There are actually lots of other slides also. Next to thanks also, there are lots of other slides. You can convert into PDF and give it, madam, no problem.
Okay, okay. Thank you, sir. Thank you once
Okay.
again for your.
Thank you. Thank you very much.
your
Thanks
for
for
this
giving
workshop.
me opportunity to talk to these people.
Yeah, I know you since 2 decades, sir. You are very hardworking and covering on the Dharwad Craton. So really very happy to see you, sir.
Okay. Thank you very much, madam.
Thank you. And I think with this, this technical session of technical session 5 is over. Tomorrow we will join for the next technical session at 9:30 a.m. Thank you so much. The link is the same. You can join with the same link, which is given earlier. Thank you, sir.